will be a star freelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
I would like Python to help me print the following on the screen. Learning Python programming has been fun. What should I do? This is the second subtopic in print we want to do. Using print to print literal string or text on the screen. Whatever you want Python to print on the screen, put it in between this single quote. This is what it's saying. You can also use the double quote. So whatever you want to print on the screen, simply use either the double quote or single quote. I can print anything I want to print. Okay? Just like that. The first one we did was printing a new line on the screen. But this one is, you have a text you want to print, just print it like this. But remember that if I wanted to print just an integer, I can print. The reason why I'm putting this here is because what is here is a string. Okay? What is here is a string. Okay? What if I have something like, say this is a message. I say, hello, my friend. I run it. This is now residing at this variable. So I can also use the print function to print it. And if I want to put this one here now, I will not use the single or the double quote because this is a variable. Here, because it's integer, and if I run this now, I still have this printed. Okay, depends on what you are putting here. If this is a variable, no need to put the single quote or double quote. If it's a string, because string, to know that something is a string, you either use the single quote or the double quote. If it is just a number that is integer, you put it the way it is, no need to put single quote or double quote. If it's a float, the same thing. You can put something like 0.90, the same thing. You don't need to put this inside what? A double quote or a single quote, whatever. I want you to know about Jupyter Notebook. If I say 78.90, if I enter, it's giving it to me the way this print is giving it to me, because invisibly Jupyter Notebook put print in display. When you put something like this, you know that you are telling it to print. For instance, if I copy this guy, the way it is now, I just put it straight here. It's like I'm telling the system to print it for me. But if you want to show it literally, you just put it like the same. You are given A, B, and C to produce D. A, if you have. B, questions. C, use the Q and A. It says if you have questions, use the Q and A. If you want to concatenate strings or items in Python, use the print statement. We're going to call, let's copy this. You drop this first. You use the plus sign. Then the second one, questions. Then another plus. They use what? Q and A. Q and A. Using this now, we have merged this together. See here, we don't want this. What you can do is to say plus again. You tell the system to use this one space. Give a space in between. Here, plus again is space in between the two. You run. See? If you have question, use the Q and A. But there's a comma here between this. You can go further to put another plus. Then you put a comma. You run again now. See? If you have question, use the Q and A. If you want to put full stop, actually it's not here. You can still go ahead and do that. Say plus, then full stop. If you have question, use the Q and A. With Python programming, demonstrate how you will use print function with list, tuple, set, dictionaries, string, integers, float, and complex objects. Okay. If you want to use print with list, we know list is anything in between the square bracket. So I can put something like 2, this, and this. This is what I will simply do. And if I run it, it's showing me this. Okay. Let's now look at how to use it with tuple. I will know for tuple is anything between the curly brackets. Okay, let's see. Anything between this without key function is called what? A set. If I run this, Still okay. What about dictionary? Dictionary is simply anything between curly bracket, but it must be what? Key value pair. If I run this, it's okay. What about string, which we have actually treated, just to say this is lovely. Okay, now let's continue. The next one I want to look at now is an integer. Okay, the next one we look at now is a float. Okay, then the complex numbers are things like this. If you have done complex number in mathematics, you know that complex something like this. If we run this, we have this. Another thing we did not consider is the Boolean object. That is true, true and false. See? Print. So true and false will also come out like this. What you should know is that all these, if you put them direct, it will give you the same result or the same output. Because for Jupyter Notebook, it's like you are directly typing it between print. See? So that's why most of the time when I'm working with Jupyter Notebook, you don't see me use the print because it's like this invisible print behind the scene doing the work for me. But if you want to put it, it will not penalize you. I see that it's still giving me the same thing. For instance, I can do this. I can even add two things together. If I put print, the same thing. It will still give me what? The same result without any error. If I remove this now, for instance, it will still give me the same thing. Okay, and so on and so forth. What if I add just a number to this? It add this one to this one. What if I wanted to add something like 4J? You see the way it's giving it to me? And I can also put print to wrap them. You're asked to get his age is 40 and single from this multiple arguments. His age is 40 and single. What I'm trying to do, I'm trying to use questions to teach you something, okay? What I want to do now is how to separate multiple arguments in print. If I say print his age is 40 and single, for instance, if I do this, I have error because this is what? An integer. If I put plus here and I put plus here, definitely it's not allowing me. It's saying can only concatenate string and not integer. And this comes as integer unless I want to put this one as a string. And look at what I'm getting. So if you want to continue the same way it is, all you have to do to separate multiple arguments like this, simply use the comma and comma. This is the purpose of this question, to teach us or to show you how to use comma to separate multiple arguments. You see, it's perfectly okay. For instance, if I want to know my login, what I will do, I will import OS. Then I can now print, for instance, say, let me use this one again, multiple argument. I will say comma again with login, then say comma, then I say os.getLogin. This os.getLogin will fetch the username I use to log in. If I run this, see, it give me done in place of this. But what I want you to appreciate is that this comma, and this comma I use to separate multiple arguments within print. I can remove this one, for instance, put something like what? A tuple. See, it's not penalizing me. I can come here to, before this guy, okay, I want to put a set. The system will return error if I don't put a comma here. Let's see. See? So this comma will help you to what? To invite multiple arguments within the same print. So now you know how to use comma to separate argument that you want. But if you want to join two strings together, you want to concatenate, there's no problem. You can still use this one to do it. See the way it is? But if you don't want to use comma, then you have to use plus. See, join together, you have to also use white space to separate the two. This is a long process. Simply put comma to assist you to separate these two strings. You can bring in a float here again for something like this. You can see it's an error now because there's no comma here. If I put comma here now, that error will disappear because this comma is telling the system that this is a separate argument, this is a separate argument, this is a separate argument, this also is a separate argument. Hope you understand how to use comma to separate different arguments within a print function. In the previous challenge, you were able to separate different arguments with commas. Once you put a comma in between two arguments, a white space will separate them. What if you want to use other separator aside white space? How do I mean? If I say print hello, I say word. This is considered as an argument, another what? Argument. If I put a comma here now, I will have a white space in between them. If I don't put anything, I have this. And if I put a plus too, I have this. So putting a comma will give us what? A white space. But what if I want other thing outside white space? Then you have to introduce this called separator. What do you want to separate these two? For now, there is nothing here, so they will join together. If I put a white space will be introduced. Assume I don't want the white space, I want heart. Assume I want two hearts, I want white space here, I want white space here. So this help us what? To separate arguments. What if I have a third argument, say hello world? Let's say I put this one as exclamation mark. Same thing. As long as this and this are here, they will both inherit whatever that is here. Let me put it like this. Oh, okay. You can see it, I have error here because I should have put another comma in between, because this an argument now, this another argument, this another argument, this an argument. If I run it now, you see the way it is done. Okay. If I put a number here, let's say 49, for whatever reason, and I put a comma in between them, you see. So if I don't want this all joined together, if I just want white space like this. Okay. So what if you don't want to use the separator, but you want it to still appear here? You can just put none. This invalidate this. That means it's as if you never use it. So if I remove this, for instance, from here, okay, let me leave this. I just copy this, paste it here, remove this. Let's see if there's any difference. See, there's no difference. By putting none, it's like you never use this. Okay. If you want to use it, you put whatever you want to put there. With what? Single quote or double quote. If I use double quote, the same thing with space. Hope this is understood. Thank you for viewing. How can you help to print Peter, Mike, and Kate in separate lines? We are still going to use print, but want to print Peter, Mike, then Kate. If we go ahead and do this, they are on the same line, but want to print this thing in a separate line. All you have to do is divide this argument called separate. With this one now, you can tell the system to print on separate line. If I run this, it will not do that. See? But you have to put new line. This means what? New line. If I enter Peter, Mike, Kate, and what? Or separate lines. Use this sep. Then you put this for new line. So this what you should do when you want to print anything or separate line. If you want more than one line, you can separate them. Separate this from each other as many as you want. You can continue to increase the distance between these arguments. But that's not what the question says. It says what? Just what? Separate lines. Hope this is understood. Thank you for viewing. Demonstrate how you can achieve this using the print separator. I think it's very direct. For instance, you put this one as a different argument. You also put this one as a different argument. Then you call the sep equals to this. If you run it now, we have this. Okay. Hope this is understood. Thank you for viewing. How would you achieve the following comma separated values format? That is CSV. How can we achieve this? To achieve such, say use print, put one as the first argument, then we put Peter Brown, then we put what? Shoemaker. Let's see. We are not achieving this. And to achieve that, we put this argument, sep, then we put a comma, because we want comma to be in place of all this. Because if you don't put this comma here, this comma will disappear. This comma will only separate the arguments. If I run this now, you see, it's like CSV. So what you need to do for the second one, just to repeat, just the way we did the first one. Say Andrew Lee. Say this is a teacher. Okay, see this number 2. To go for number 3 now, Matt Eriks. Say dancer. We run this. So we should have done something like this. Just copy this, paste here, copy this, paste here. So if I run this now, I will have all of them as it is here. So what I want you to understand here is that we can achieve CSV format with this set, with the comma here. Hope this is understood. Thank you for viewing. What if you wanted to get one line output from the following by disabling the new line? All you have to do is to introduce end argument, this end keyword argument. If I run this, you see that they are now on the same line. So if I continue the same thing, you see that what? All of them are now on the same line, but there's a problem. The problem is the comma has disappeared because we removed the separator, okay? So now let's go back now. Instead of doing this, say comma, let's introduce the head keyword equals to this. So let's run this and see. You see, all of them still appeared with this. So all we need to do is just to take this and put here. They put it here. It's not even necessary here because it will still be on the same line. So if we run this now, see everything's on the same line and these numbers are still in place. But we have issue here whereby this one now is not close to this. Okay, so let's put a space here. You see, the space has been introduced. We put a space here now. Just look at this, what we have put here now. You see, we have this, okay, because we put this here now to give a space between this teacher and this three. Okay, what if you want to put something else like this? You see, you can do the same thing like that. Can I even put something like that here by saying, let's put at this time 3 at, you see, so you can manipulate it as well. Hope this is understood. Thank you for viewing. What if you are interested to print the following people are great, Peter, James, as this in this format? Let's see, print the following people are great. Okay, if I run this, I will have it on the same line. The best thing to do is to put this. This one mean what? New line. This one mean new line. As long as there's a single quote, rapid this, or as long as this is within a single quote or double quote, definitely you have them what? In a new line. If you want more than one new line, you can run it like this. If you put just n, it will not work. To tell the system that what is coming next is special, you put what? This backslash before the n. Just like for tab, you put backslash before the t. So the system knows that the combination of these is what you are referring to. The combination of this is what you are referring to. Okay. So once you run it, you have this. So this challenge is just to show us how to include /n within single quote or double quote to have something like this. Hope this is understood. Thank you for viewing. Edit the following without removing the n keyword argument, this and this, to achieve this on a separate line and this on a separate line. Okay, let's see. If I move this now, I put here. If I run this, I will have this on the same line. We are asked to edit this code without removing this to achieve this. To achieve that, we simply put this. We also put it here without removing this. See? What this want to demonstrate to you is, as long as this is within either a single quote or a double quote. If I put double quotes here now, see, I'm still achieving the same thing. Using this within this end keyword argument to achieve a new line. Because originally, it was meant to remove the new line. See? Because if we don't use it at all, it's the same thing to have what them in a new line. So once you introduce them, they were meant to remove the new line. Okay? If you don't even put this one here, it doesn't matter. Okay? But now, if we must achieve this kind of format with this end, see here, we need to put this. Hope this is understood. Thank you for viewing. What is the use of modulo in Python? That is this symbol. There are two things. First, it's used to find remainder. How do I mean? If I say 4 divided by 3, you have this. But if I say 4 modulo 3, I have this. This means that if you divide 4 by 3, the remainder will be 1. Okay? What if I say 4 divided by 2? I have 2. But 4 modulus 2 is 0. It means if you divide 4 by 2, you're going to have 2, but there's not going to be any remainder. That's why it's giving you 0. So this is one of the use. But there's another use of modulo in Python. It is called the string modulo operator. Though the symbol is the same, the name is the same, their work is different. So secondly, it's used for string formatting. Let's see how. You put the format on the left hand side. Let's say this is format. Then you put the modulo, put the values. Okay? If I say print, I will put the format on the left hand side, put this modulo, then I will put the value here. The value will be here, the format will be here, This we separate them. When I say format, how do I mean? D, for instance, represents integer. S, for instance, represents string. So if I say, for instance, modulo S, it means on this other side, this one is expecting what? A string. Let's say hello world. If I enter, I have hello world. So this is corresponding to this. That is one. Let me extend it further. I want to put something else before this. What I want to put here now is modulo D. That is what? Digit. That means this is expecting what? A number. That is integer. If I put, for instance, this, I put comma. This will go for this. This will go for this. The purpose of this is be expecting what? Integer. Be expecting here a string. I can even tell the system or somewhere here, anywhere I want to put it, even before this guy, be expecting a float. Then I will come here and I'll put a float. Let's say 2.5, comma. Let's run this. You see what happened? Expecting a float, it got this. Expecting digit, it got this. Expecting string, got this. And you can see the way they are arranged. The float, the digit, and the string. But what you should say about this now is that, though I put 2.5, it converted it to this decimal place. What if I don't want this? I will tell the system, after this dot, I will put dot here. How many decimal places do you want? I can say 3 decimal places. So this one will go to 3 decimal places. If I copy this, for instance, I put here, I run it now. You see? Now it's now in 3 decimal places. 1, 2, 3. If it was 2 I wanted, I put 2. If it is 1 I wanted, I can simply do it like this. That means there is no decimal place. This is 0. If it's 1, you put like this. If it is 2, you put this. If it is 3, you put this. If it's 4, you put, and so on and so forth. If I wanted to put $sign, put this in 2 decimal place, I want to put the $sign here, even the @ sign. You simply put it before this modulo. That is to say, if I put @ here now, that means @ will come before this conversion. So this guy is for this, but something will definitely come before it. If I run this now, you see? So if I put a $sign, you see? This modulo is used for 2 things. The first thing is if you are looking for a remainder. And the second thing is if you want to format a string. Hope this is understood. Thank you for viewing. List compression. List compression is using a single line to write something without written with many lines. For instance, if I want to get, say for I in range, let's say 5, I say I want to print I will have this, okay? There's another thing I can do as well. I can come here now and say, okay, declare a list. Say list equals to nothing. Just declare that list. When you are doing this, I want, instead of printing, I want you to append list.append I, okay? Then print list for me. Each of this I that is coming, instead of printing it like this, put it inside this list. If I run this now, I have it in this format. You can see how many lines? 1, 2, 3, 4. 4 lines. I want to get the same thing using 1 line. What I want to use is this, okay? I give this, then I just take I put it before this. What I've done, this is the expression, this is the for, and this is a member of this iterable. If I run this, see, I'm still having the same thing. Just using 1 line, I'm realizing the same thing which this one did for me. This is called what? List comprehension. Using 1 line to achieve something like this. Remember, what you want to be here, what to be printed should be here. Okay, now let's copy this time. What if we want to square all this value? As we want to square all these values, square of these values, we can say this. We can do this. That means the output will be this one multiplied by itself, multiplied by itself, multiplied by itself. If I run this now, you see, we are having 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is this. Can go further to say, okay, instead of doing this, why not multiply, then you see divide. divide by 2. Let me just do this. Why am I doing this? Just to show you what is possible. See, I'm not divided by 2 now. Divide, after multiply each of the supply value, divide by 2. This will bring the data. This will produce the output. Hope this is understood. Thank you for viewing. The question says, what if I have if statement with for loop? How should I arrange the list comprehension? What we are saying, for instance, if I say for I in range, say 12, say print I will have all this, right? What if I wanted to list from here? I will say, okay, let me say list equals to this. Then I need to put pend instead of printing. Say pend I. If I look for what is list now, I want to print list. I will have all this. So let me just make everything one cell. Let me say print list. If I run this, I have this. Now, what I don't want this group. Assume I don't want this group. I only want from 5 to 11. I come to display. I say you will only append if I is greater than 4. Then you can now what? Append. If I run this now, you see, to achieve this same thing, other list compression, we simply take this, our data source. This will give us the data. We still want the output here. Then this condition should come immediately after this. Then let's run it. We have the same output. So if you have if statement, still follow the same method, you can put this at the end of the page. The system knows what to do to produce you what? The result. Note, the first time, what we did, we only have this method. If I run this now, we have all this, right? But if I put this here, the if condition, I will have this. Just as if I remove this from here, I will have all this. If I put it back, I will have this. This comes after this. The same thing goes, this comes after this. But this output or the expression is still before. Hope this understood. Thank you for viewing. Use list compression to write the following Python program. That is this. Okay, before we do that, I'm going to copy this. I will make this available to you. Then I'm going to paste it here. Let's run it. Okay. In place of one, odd, okay. What it means is, if it is even number, you put the value. If it's odd, you type odd instead of the number. That's what this is doing. And this question says we should use list compression to do the same thing. Okay. The first thing I will do is to pick this, put inside compression. Before it, my output will be here. I've told us that if comes after this. If we run this, see what we are having? We are having 2, 4, 6, 8, 10, 12, all the even number from 1 to 20. That's what we are having with this. Why? Because it says, give me this only if when you divide 1 by 2, there's no remainder. Agree with me? 2 divided by 2, no remainder, no remainder, no remainder. For 3 that should have been here, there will be remainder. This one is saying you should do this for me if this is correct. Now there is ends. Listing, when there is ends, this if cannot be here anymore. You need to come before the for. Okay? The ends. You print what? Hot. You see, if there is ends, take everything, put before the for. If we run this now, you see the same thing. Although it's arranging it like this, the same thing, just because it's very long. If I reduce this to, let's say 10, you will see on the same line. Just the way if I put 10 here now, you see there's no difference between this and this. Using one line of code, create a list from 60 to 100 with step of 5. That's to say, range 60 to 101. So let's see, for I in range 60 to 101. You already know why we put this, because we need to end at 100. Step of 5 means we put 5 here. If we run this now, you see, we start from 60. If you add 5 to 60, you have 65. You have 5 to 65, you have 17. You add 5 to 70, you have 75. You add 5 to 75, you have 80, and so on and so forth. Hope this is understood. Thank you for joining. Write a Python program to take a sentence from a user, account the length of each word in the sentence. Only the words that are more than 4 letters should be counted. include list compression in your program. Let's see. The first thing we need to do is to accept input from a user. So I will tell the user enter a sentence. For this, I will say string dot split. This method works what? String. So this string, whatever sentence that is given, will be splitted with this method and to be stored here. If I say print each, for instance, can do this. If I enter, you see, each of them is splitted. Let me also print string before that. If I enter again, this lovely program was entered. Each of them was splitted. We want to count all this. And what we are counting, the length must be more than 4. Assume we want to count this, we will not count this. This will not be counted. This is exactly 4, will not be counted. This will be counted. This will be counted. Okay? I will say that. Let's continue. We're going to use list compression now. To do this, we want to get an output, and the output is to count. So we're going to count, let's say, I. So what is I? For I in each, that is, this is I, this is I, this is I, this is I. They are coming from this each. Okay? For I in each. Okay? But we gave a condition. If the I is more than what? 4 letters. So we're going to say if the length of I is more than 4. That's where you should count this. So this will return the output. But we need to store this T in a place. Let's say count, for instance. Let's say count. Let's just include here. Let's say string. Here, let's say splitted. Now let's run. If I enter, look at what it did. Let's separate this with this. This count need to be printed out as well. Let's include that. Print. Let's say count. Then we count, paste. See? Now look at this. This is exactly 4. It will not be counted. This is less than 4. This is 5 counted. Less than, less than, less than, less than, less than. Okay, this is not less than. This is Bootcamp. Counted to be 8. Less than. This is 5. Not less than. This is exactly 4 cannot be counted. Exactly 4 cannot be counted. Hope this understood. Thank you for viewing.
Using one line of code, find the list of odd numbers between 0 and 50. Remember, it says it's a list of odd numbers. So it means our output must come in this format, and the odd numbers such as 1, 3, 5, till we get to 50 should be here. And the next thing you ask yourself now, how do you get this? You use what? The range of 51. Why 51? Because range means, if I say range of 5, for instance, it will be 0, 1, 2, 3, 4. It will end on the number before the number you put here. So because we are looking between 0 and 50, we have to put 51 here. Okay, but it says we should use what? One line of code. Because it's one line of code, it means we are going to use what? List comprehension. How do you tackle this? You put this so that the result will come in between the square bracket. I'm going to say odd. Odd will be the result. It should be at the left hand side. Remember, you can choose anything. I can choose S, I can choose P. I'm only putting the odd. That's my style. You can choose your style. It doesn't matter. Okay, let me just put I here so that some people will not think that I'm putting odd here because we are looking for what? Odd numbers. S, then I'll say for S in range 51. Okay. What should I do? Because I'm going to check for odd numbers, and why checking for odd numbers? You have to say if, for instance, S modulus 2 is equal to 1. Okay? Because I'm using S now, whatever I will get from here, odd number is when you divide by 2, you must have 1 as what? The remainder. I know the numbers lives between 0 and 50. If I run this now, for instance, I have all this. See? And this is not what I want. If S modulus 2 is equals to 1. So these are the ones that should skate through. If I run this now, you see, it has changed. Now it's only the odd number that we see here. All this is understood. Thank you for viewing. Using one line of code, replicate this list. Okay? We are meant to replicate this list using one line of code. That means we need to use list compression to produce this same list. We're going to assign this to a variable. Let's say d is equals to, okay? So if I put d here now, we have this. We want to replicate this same list. Assume I say e is equals to this, then I need to produce this. All I need to do, I will say for num in d. What do you want to do with them? Give them to me. So this will be the output. So this will loop through each of these. As it's looping, it will be picking each of them, replicating them into this new variable. If I run this and I click E, we have what? Similar what? List. Using one line of code, create a list from 60 to 100 with step of 5. That's to say, range 60 to 101. So let's see, for I in range 60 to 101. You already know why we put this, because we need to end at 100. Step of 5 means we put 5 here. If we run this now, you see, we start from 60. If you add 5 to 60, you have 65. You have 5 to 65, you have 17. You add 5 to 70, you have 75. You add 5 to 75, you have 80, and so on and so forth. All this is understood. Thank you for viewing. Given num is equals to this, use one line of code to create a new list by multiply each element in num by 10. Okay? We are given this list. Okay? We enter. So num is this. We are asked to create a new list from this list, but we have to multiply each of these by what? 10. That is to say, anything you want to put, I can say t for t in num. Okay, this will produce what? This back again. Let me just drop it and I'll show you. Exactly the same thing. But the question says, we want what? Each of these to be multiplied by what? 10. All you have to do, you multiply by 10. If we run this back again, we have what? Each of these elements multiplied by 10, then we have this. All this is understood. Thank you for viewing. You are given t equals to this and asked to get a new list containing the square of each element in t. Only square above 100 should be in the output. What would you do? This is a list given to us that t is equals to this. Okay? Now we are asked to get a new list. In this list, assume I say this is the output. For the output in t, what should I do? I should square this. Squaring means out multiplied by out. But the out, this guy, must be greater than 100. That is, this one should come into the output as long as it is greater than what? 100. Let's see. Look at it. If we have not put this, for instance, I will run this. We have all this. From 25, square this, square this, square this. Have this, square this, you have this, and so on and so forth. But the question says there should be restriction. That means only the square of these three elements skate through. All this is understood. Thank you for viewing. Given this dictionary, which represents the names with ages of people, create a list of names of the people. Before we continue, let me first of all take this guy, then put it here. I want to explain something here. Remember, in dictionary, this means what? The key. While here, after the colon is a value. Okay? If we are going to use one line of code for this, though it is not stated here, if I say, for instance, A for A in D. Okay? What am I referring to? Is it the key or the value? If you see anything like this, we are referring to what? The key. Okay? This will produce the key. If I come down, it says what? I should create a list of the names. And the names are what? The keys. It means I should simply say, for instance, I can put A, I can put S, I can put anything. Let me just say key for key in D. I run. See, this guy produced the list of names of the people. Hope you understand this. Thank you for viewing. Given this dictionary, which represent names with ages of people, create a list of the ages of the people. This time, want to get these values from this what? Dictionary. Okay? So let's drop this first. If we want to get the list of the ages, age for age in D. What is this? If I leave it like this guy is going to produce what? The key. But I want the value. I want this value. I want this value. How do I get that? To get that, remember this one. If I want to get this value, for instance, I will simply say D, then I put this one, I put 0. If I want to get this value, for instance, 0, 1, 2. To iterate and to get each of the value, all I need to do is to simply say D, then just the way I did this, then we can put whatever I want to put that's here. Just like what? Age. Okay? It means, let's run it. You see? These are the list of what? These values for age in D. Hope this is understood. Thank you for viewing. Given this dictionary, which represent the names with ages of people, create a list of names of people above 30. Okay? This is what was given to us. We are asked to get a list of names of people above 30. And names simply means what? In this place, the keys. So I can simply say name for name in D. Okay? This represents the key. But these names, if name is greater than what? 30. If you run it like this, you're going to have error. Because names here is key. And key is what? A string. And if you say a string more than 30, the system will be confused. So we need to have a way of taking the value. And to take the value, as we have seen, simply say D, name. This represents the value. So we are going to replace this with this. Now put greater than 30. Okay? So therefore, simply put this, put what? D here. If we run this, we find out what? It's only Andrew and Ben that are what? Above 30. Hope this is understood. Thank you for viewing. Given j is equals to this, find the list of the square of the negative integer of j. Okay? To get that, we drop this. We can say k for k in k. But what is k? K, as far as this is concerned, is each of these value. If you want the negative k, you must say if k is less than 0. Anything less than 0, any integer that's less than 0 will definitely be what? Minus. If I run this for instance for now, we are making a mistake here. This is supposed to be in j. Okay? That is in j. We run this, we have all the negative values. So for k in j, if k is what? Less than this. But the question says we should find the square of each of them. This. So the square of minus 4 is equals to 16. The square of minus 7 is equals to 49. That is this multiplied by this. Minus and minus will give you plus. This will give you 49. Hope this is understood. Thank you for viewing. Given that cars is equals to this, okay, using a single line of code, get the name of cars that end with A. The expected output is this. But what you should see here now is that these are small letters, but this what? A capital letter, this uppercase. And to work on this, we have to either convert all this to uppercase to join this guy, or we convert everything to lowercase so that everything will be uniform to join these other guys. The first thing we're going to do, we say for anything you choose, for I in cars, okay, they will not say, if you can get that, check if each of the elements ends with A, please help me convert. See, if I dot lower, then dot ends with, then we put A, okay? This is the one that we come through. We are filtering at this point. That the one that we come through, you have to check if it ends with what? A. After converting, print I. It says cars is not defined. So let's run again. See, this is the output. Toyota, Honda, Tesla, and Tata. Just as we have in this place. Okay, now let me show you what informed me to do it like this. Very easy. If I copy this, for instance, I can put here to say, you agree with me, that is correct, you are used to that. I can also copy this, paste here. You see? For I in cars, then if all these ones are correct, just to show you, I will simply say print I. You see? If we wanted to get it exactly the same way, remember we are not going to use print. We are going to declare a variable, then we append each of these to the variable. Hope this understood. Thank you for viewing. Given Y as shown below, use a single line of code to create a new list containing elements of Y that start with A and with a number of characters more than 3. So what it's saying is that the number of characters must be more than 3, and this particular element must start with A, such as this. This one is not more than 3. This one is more than 3, and so on and so forth. If I look at this, I will start with for loop. Before we do that, we need to copy this and paste here, just to set the value of Y. Having done that, I will come here to say for I in Y, okay, so what do you want to do? If I dot, then say start with A, okay? But it also says that what? And the length of character of I should be more than what? Then you have to print I, apple at what? Ashada. Given Y as shown below, use a single line of code to create a new list containing element of Y that start with A, end with A, and with a number of characters equal to 3. Okay? And if you can look at that condition with this one alone, first of all, sort, start with A, start with A, start with A. Then you look at the end with A. Then you now check this condition. This cannot go, this can go, this cannot go, this can go, because it must be equal to 3. And if you want to do something like this, first of all, let's put Y as the input. Okay, then we put this for I in Y. If I dot lower dot, let's say start with first, start with A, then or this ends with A. Just copy this, change this one to what? End. Okay. If these two conditions are okay, that is, these two conditions are okay. So let me put this one inside a curly bracket. Then you do the final one, which is and length of I must be equal to 3. Let's run. When we run now, we have this and this. I think this is self-explanatory, and if you don't get it, all you need to do is simply copy all of them here. I put this, then you run it like this. The next thing you should do now, you put this again, you print I. These two. This is just to verify, but this is the solution. Hope this is understood. Thank you for viewing. What is the maximum integer of each of the following sublists? Using a single line of code, create a new list for the maximum integer. Okay, these are the sublists. We want a new list that pick the maximum. The maximum here is what? 8. The maximum here is what? 8. The maximum here is what? 9. Here is what? 9. This is what we want. This, and this. Maximum of each of the sub lists. How do you do that? Simple. You come here. You simply say for I in B. We don't have B here, so we need to come here first. Put B, okay? Then we put something here. Remember this I now represent this, and this. Why loop it? So we say mass, then we put I. This is like what? If we run this now, we have what? This. 8899. Jupyter Notebook is helping me to, I've said it several times, that Jupyter Notebook is helping me to print. But normally, I have to do something like this. Let's say C is equals to this. Then after doing that, I will now print C. Same. But this is the line of code we are talking about. This is not part of it, because this is just to show us what we have at C. Hope this is understood. Thank you for viewing. Given that LST is equals to this, using list compression, remove the inner square bracket and make everything one list. We want all this removed. This one, remove. Remove all this inner square brackets. Then let everything flow together. How do we do that? First of all, let's put the input. Okay? Then we run this. The best way, as I've said before, you start with 4. For I in LST, this one we pull each of these. Like we pull this, to pull this, to pull this. Because for now, these are what? Elements of LST. So when you get this, for instance, when the system gives you this for I, what do you want to do with it? I still want to strip this guy naked too. I will go further to say, for another thing, there's a T. You can put anything for T in I. Remember, as at this level, this is what you have. But from here to this place, the output you have here now is I. This I is waiting for you to use. What do you want to do with the I? I'm not saying, okay, another variable. I want to say T now, or anything you want to put here. I can say num in I. Remember, if I say in I now, if we are looking at this first one, it means we are referring to each of these. What do you want to do with them? For num in I, give them to me. If I say give them to me, you put what you want the system to give to you behind this first 4. The next thing I want to ask you now, do you want the system to give you I, or you want it to give you num? Num is the final thing it needs to give you, because this one only gives you this to use. Then it gives you this one to use. And when it's giving them to me, I want to pick each of these. So each of these is represented by num. But why all these ones are represented by what? I. So if I put num here now, I run. See what do we have? We have all the inner square bracket removed. Everything is now one list. Hope this is understood. And remember, if you don't understand this, simply come to this place. As I've said several times, just put it here. For the first one, slide it. Then to check if you are correct, simply print num. Then you run. And then, I remember print has what? Empty new line after each printing. If you want to remove that, you can put end equals to this. So everything be together. If you want to separate it, separate like this. This is just to check. But to pull this one and this, you need to apply either you put, let's say something like u equals to this. You define a variable, then you, from this place now you append before you print u. But we are not interested in that, because this is just what? List compression. I'm just only using these guys to show you these elements. But this other thing, like the square bracket and the comma, that will be what? Automatically inserted, be provided by this square bracket in your list compression. All this understood. Thank you for viewing. This one is like the previous challenge we just done. The only difference is the integers in the new list must be above 6. Okay, so let's copy this again. Let's do what we did before. You have all this. But this question says this
1. There must be what? More than 6. Then you come to this place. If now I have this, as you can see, all these values, they are all more than what? 6. Hope this is understood. Thank you for viewing.
Given that S is equals to this list, create a new list for the string in S that are uppercase. Create a new list for the strings in S that are uppercase. Okay? We are going to take this. Uppercase means everything, like this one is uppercase, this not uppercase. Want to get those that are uppercase. I will need to use one line of code, though it's not stated. That is where we are in this topic. Simply say for I in X. Remember, I always use I. You can use anything. You can say in S, in S. You can say string. Okay, let's use string. For string in S, what do you want to do with them? If string is upper, then what do? You print string. We run. If we run, we have what? BMW and what? ABC, because they are what? Upper. All this is understood. Thank you for viewing.
Given that S is equals to this list, create a new list for the strings in S and their corresponding length. The string must start with A or ends with A, and the length must be less than 5. Okay, this is the given list, and the expected output is this. Okay, that is the string and the length of the string. Okay, now let's see using one line of code. We start. The first thing we need to take each of them. So I will say for I in X, that's the first thing. So if I get this, for instance, what do I want to do? I will simply compare. The first comparison is if what I have now start with A or ends with A. That means they have two, right? Then I use the curve bracket to test. I say I dot, let's say lower, dot, start with, because the first one says starts with A. The next one says or. I can put all like this or use pipe. I haven't done this. I can simply copy this, put here. All I need to do is to remove this. I say what? End with. After completing these two, I will come back to this place. I say what? If length I, that the length of I is greater than 5. If I put I here now, remember I will not have anything like this. Let me show you first. If I run this, see what I'm having? Oh, sorry, it's a less than, not greater than. Okay, we have this. Okay, now we are getting there. We only have this, but not their corresponding length. Because it's a what? Their corresponding length. To get their corresponding length, now because of this square brackets, it means here square bracket, then we put the length I. All this understood. Remember, do whatever you want to do first before you come to this side to get the exact output. If I put something like this here, that is, if I put curly bracket, you see, I have curly bracket. If I put a curve bracket, I have this. If I put square bracket, I have this. All this understood. If you don't still understand this, it's very easy. Start from here. You copy a paste. You go down. See? Copy this. Paste. Furthermore, sorry, I should have enter. You come here too. You copy this. And this should make meaning now. After this, I cannot print the output. Print the output. Let me just print I. Have this too. If I want to print I at the length. But remember, as I said, when you do something like this, what gives you this comma, and this is this square bracket. All this is understood. Thank you for viewing.
You are given this list and asked to get this list. What would you do using a single line of code? The first thing we need to do, we need to analyze what we have and what we need to get. This is what we have. we are asked to get this and this from this list to have this. The first thing I see is they are what? 9 what? Uppercase. Okay. We are going to do to upper. We also have that these two, they start with A. They both start with what? A. Okay. Another thing is, even this one start with A, even this one is capital letter, but there's something. How many characters here? 1, 2, 3, 4, 5. So we're going to do the character should be what? Greater than or equal. With these 3 features, we can achieve the result. Let's see. In case you don't want to do it straight, it's better you use the for loop method. Let me just say v is equals to this. I run this first. Then I can use the for loop method, say for I in v. Okay. If the length of I is greater than or equals to 5, then we can filter mode, say if I start with A, then we can get our result, and the result we are going to get, we are going to turn it to what? Uppercase. Okay? This shows that what? We are going to have what? The expected or the desired output. So all you need to do after this is the result. Simply copy this first. You want to do it, or just start from here first. Put here. But this is not the way I will do it. I will do it straight. I just want to show you that what? There is no difference. Then I pull this one too, paste here. Then I copy this, paste here. Okay? If I run this now, we have exactly the same thing. Hope this is understood. Thank you for viewing.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
S is equals to this list. If this single line of code is executed, this will be produced. If you are asked to put the one line of code back to the normal for loop, what would you do to achieve the same result? Okay, what it's saying is this is given to you. Okay, then if you apply this, we have this. We are asked to put this one back to the normal for loop to achieve same result. What I will do, I will simply start from here to this place. Then I will pick these two to the end of this place. Okay, I will take this now to this place. Okay, the next thing I need to do now is to go get a place I will put the result. I can put anything. Let's just say new list equals to empty list. If this is achieved, what we need to do is to append now. What do you append? You take this and append each of the results that is coming. You append J. If you run this now, before I run that, why not just print everything in the same place? Let me just print new list. If I run this, I have what? The same result. But there is issue here now. The issue is this, small letter, and everything here comes as what? Capital letter. I know it's referring to this N, but this guy produced what? Capital letter. So that means we need to come to this place, as you can see. We have this. That is to say, before you can append, we actually need to what? Turn it to what? Uppercase. Then we run. As you can see here too, the same thing was done. So from now on, you should be able to move from single line to, let me say, multiple line. Write a Python program to tell if a letter is a vowel or a consonant. Look at this. These are vowel sounds. All these are consonant. This is either a vowel or consonant in the person where it is used. This question is asking you to write a program. Whenever you, for instance, type N, the system will tell you that this is consonant. If you type U, the system will tell you that this is a vowel. So how are you going to do that? The first thing you need to do is to separate those ones that are what vowel, because there are few in number. These are few. Since these are not many, it is better to what? To have this one separated from every other one. Then you can start your program. So to do it now, we simply say, okay, first of all, give us an input. We need input from the user. Okay, that input to be stored here, whatever input it is. Okay, let's say give a letter of your choice. Okay, then we are going to add the system if I in this place, or I in the capital letter of this, because these are small letter, capital letter of this, A, E. If they are here, print what? I, comma, is a void. Let me just choose any of this. If I put A here now, say what? A is a void. Okay. If I put O here now, you say O is a void. But what if it's not here? What if it's Y? Else if I is equals to either small letter y or I equals to capital letter Y, print what? I is either a void or consonant. Okay, so if I run this again now, if I put like Y here, see, Y is either a void or consonant. If I put I here now, say what? It's a void. Okay, I've done that. What if I give G, P, K, which are consonant? So all I have to do now, I have to end it because there's no any other thing after consonant as far as alphabets are concerned. I say ends. Print I is a consonant. If I enter, if I put R now, see, R is a consonant. If I put O now, O is this, a void. If I put capital letter P, consonant. If I put capital letter Y, says a what? Void or consonant. We can either change this as well. We can format this to say, okay, instead of putting it here, if you want to do it, let me just do for only this. I can say percenter S, then I will come here now, say percenter I. Just for only that. If I do Y now, you see, still the same thing. This is what formatting with module. Okay, I will format this one as well with, let's try this one too. Let's see here now, we're going to put curly bracket for this. They'll say dot format. We put what? We put I. If I run this now, for instance, I put T, say T is a consonant, refer it to this place. If I run this, I say U, say U is what? A void. Hope this is understood. Thank you for viewing. Write a Python program to get the number of days in a month if the name of the month is given by the user. For example, if a user type March, the system returns 31 days. There are many ways of doing this. I will show you two methods. The first thing you have to do is to tell the system the meaning of January, how many days in January, how many days in February, because the system does not know. You have to tell the system because the system is a dummy. It doesn't know what is what. So what I will do, I will say month is equals to, then I'll put dictionary, as curly bracket for dictionary. So I know that in January we have 31 days. Okay. I also know that in February we have 28 days. Okay. So I will type everything, then I will come back. Okay. So the system now knows what is January, what is March, what is June, and the number of days in each of these. So the next thing I will do now, I will ask the user to input for me name of month. Okay. Enter the name of month. Okay. This input, we need to store it somewhere. See, this is month. Let me call this one month. Once the user supply me the name, then I'll have to check this name against all these names. How do I do that? I'll say, if the month the user gives me is in months, remember what the user gives me here, if it's here among this, okay, what you're going to do is print. Let me format. There are these days in this month. Then I format. What am I formatting? Here, there are what? 21 days for instance, 31 days for instance. That is what? Refer it to the months. But if I say months, which one am I talking about? Remember the user will give me, for instance, here, February, March, April, May. And if he gives that to me here, it will be stored here. And assume he gives October. That means this is talking about. To use this key to get this, you need to put what? This. Say month. Okay? That is, month is what the user will write here, like October, which will be here. This name the user gives will be searched against this month, which is all these months. We have actually treated all this. Okay. Then how do we fill this place? That is the month. Okay. There are number of days using the key to get the value in which month. That is month, comma, month. Then we're going to say ends. Print check your spelling, or this is not a month. You need to put a comma here. Let's run now. Assume I put October. If I enter, say there are 31 days in October. Let's try another one. Let's say July. If we enter, say 31 days in July. Let's try February. Yeah, 28 days in February. But there are some time we have 29 days in February. How do we do that? If we want to do that, we can just remove this February from here. We leave every other one. Then what the user gives us this, that is the first thing we're going to check. We say if month is equals to February, so print, let me just copy this. Print what? Print there are dash days. Okay, let me just write this one full. There are 28 or 29 days in February. So in February, which is the month the person entered. So if I run this again now, if I put February, if I enter, I see there are 28 days on 29 days in February. It's also telling me after doing that here, it's telling me check your spelling, or this is not a month. Why? Because this if and this if will be sharing these ends. Okay, when you use this one to get this, you also found that this one is not among this, so it evoke this one. To stop that, we say what? Ends if. They are all together now. So let's say February again. If we enter, you see this is gone. If we enter, see 31 days in March. Let's try to make a mistake. Let's say June, like this. Check your spelling, or this is not a month. This is one method you can use. There's another method you can still use. What I will do, give me the month. I will say impute the name of the month. For instance, then I will start checking now. Without even telling the system about this, I can do that. What I will do now, say if the month the user supply in, okay, that is January, February, March, April, May, I will merge them together. All this that are 31, 31, 31, 31, they will all come together. Okay, that is January, February is not. Okay, this one is also 31. All the 31 will come together. Then others will also come together. Let me type everything, then I will come back. Okay, then if they are all here, it means that we are dealing with what? 31 days. So I'll just come here to say print there are 31 days in whatever month. I can do this. Then after that one, I say, okay, if it's not there, ends if month in, I will take all this one that are 30 days. Like April is there. Let me type the other one, then I come back. I will, okay, I say if they are this one, print what? I'll just copy this now, paste here. The only thing I need to change is 30 days. Okay, then I will still go further, say ends if month is equal to, that is this place. This one, I've already done this one. If this one, I will just copy this now. I will put it here. Then I will only put ends if. If this is February, do this. Okay? Then after that, I cannot say ends. I will write this one now. Print check your what? Spelling. Or this is not what? Amount. If I run this separately, I put my chair now. See? 31 days. If I put February, see? The same thing. If I put something that is not there, say check your spelling. So this can be solved like this, or you use this method. You can also have another method. There are many ways of achieving the same thing. Write a Python program to get the media of three given numbers from a user. What this question is saying is that if a user gives you three different numbers, you should write a program to the media of the three numbers. The first thing I know is that I will get three different inputs from the user, and I will ask the user to enter a number, and this is going to be what? An integer, because input come as what? String. So I need three of these from a user. B, This will be C. So the next thing I will do now is to get the media of these given numbers. And you agree with me that in Python, if you have numbers of different values, if you use the sorted function, which we have treated, you can arrange them in ascending order. So we are going to sort the three given numbers, A, B, and C. So we sort them, Python will arrange them. Once we arrange them, this will be the media. And this means 1. That's the middle number after sorting. Okay, this will be sorted. Let me just tell the system to print what it has sorted just for you to see how it is. Then I print whatever is the media of the three numbers. Then I'll say dot format. Then I put this, the middle one. Okay, the system should print this for me. Now let's see. Enter a number. I enter 2, I enter 4, I enter 3. Okay, see, 3 is the media. How? Remember, I enter 2, I enter 4, I enter 3. It should have been 2, 4, 3. But because of this sorted, Python arranged these numbers in ascending order. And with this one, it counts 0, 1. That means this middle one is the media of the three numbers. Thank you for viewing. Write a Python program to print a similar pattern as below. 1, 2, 2, 3, 3. The above was printed when a user entered 4. Your program should be able to handle any value. You can show your solution in Q&A, but let me show you how we do this. The first thing I saw is that the user entered 4 to get this. It means the first one will print 1, 2, 3. First row, only 1 value. Second row, 2 value. Third row, 3 value. So these are rows. This is a column. This column, this column. Okay, so what is the first thing? How am I going to handle this? I have to ask the user to give me what? An input, because the question says your program should be able to handle any value. So I need an input from the user. So I will say n is equals to integer, input, enter a number. Okay, this is the first thing I need. If the user enter 5, you print a similar pattern. That's 1, 2, 3, 4. Stop. With this type of behavior, it's telling me that there's something like range. Because if I have range, for instance, range 4. Range 4 will give me 1, 2, 3. 4 will not be printed. So I will say for I in range n. What do you want me to do? This one will take care of what? The rows. For this row, each of the row. What of the column? Let me call the column J. J in range I. Because this I, we pick a value from here, put it here for me to print. Print I. If I leave it like this, I should say for J in this. Let me remove this for now. Okay. If I do like this now, I run. Let's put 4. See what is printing? 1, 2. It prints 1 for this one. Print 2 values. Print this. But it's not the same thing. We need that pattern. To get that pattern, and equals to, if I run, I put 4 again. See what it's doing? Everything now on the same line. But I don't want that. If I put 4 here again, I have this. See? 1, 2, 2, 3, 3. If I put like 10 now, let's see. See? That means this my program can handle any what? Any value. Let me just try more. Let's try 100. Okay. Let me reduce it as okay. I want to print 20. Okay, finally, let me put what we are asked to put. Let's say 4. We have this. You can also do something else. You can use another method for this. There are many ways of achieving the same result. If I have this, there's no need for all this, actually. I can simply put this here. Then all I need to do now is to say print string, convert to string I, multiply by I. Let's put 4. See, so simple. Write a Python program to count the number of digits in a given number. Input, enter a number. Okay. If you are given to me, first of all, check if it's what? Alpha. That is alphabet. If it is, I want you to print for me no alphabet no alphabet, please enter a positive integer. Okay? If it's not alpha, it might also be what? A digit. I will add the system is digit. If it's digit, what should I do? Print the number of digits. The number of digits in this place is this. Then I will say dot format. If I format now, then this is the first one. The number of digits in I is what? Len I. It is possible that it's not even a digit, but it's what? It's alphanumeric. Is alphanumeric. Then I add the system. I will say print. No alphanumeric is what? No alphanumeric is needed. No alphanumeric. Please enter a positive integer. Finally, I can put anything I want to put. Ends. Print entered is strange. Enter a positive integer. Means if all these are wrong, then you have to do this for me. Okay? If I enter now, I put 12. See? Because it's digits, see the number of digits here are 2, 1, 2. Okay? If I run this one again, if I put alphabet, see? No alphabet, please enter a positive integer. If I run, let's say I put alphanumeric, you say no alphanumeric, please enter a positive integer. What if it's not even alphanumeric? What you enter is strange. Enter a positive integer. Hope this is understood. Thank you for viewing. Write a Python program to get a multiplication table for a given integer. How do I get the multiplication table? Let me do that. It's going to be print the given number because every multiplication table is like this. Let me show you. If I say give me for 2, it's 2 times 1 equals to 2. 2 times 2 equals to 4. 2 times 3 equals to 6. Or 3 times 1 equals to 3. 3 times 2 equals to 6. 3 times 3 equals to 9. So that means if this is P, this is a given number. This is progressive. That means I can use range for it. Range what? Range whatever I want. If I want for, say, from 1 to 12, for instance, I will say from 1 to 13. That is 113. That means 1 to 12. Range will help me to get this range. This one, what will help me, as you can see, is P multiplied by this. That is, if this is the range, let's say call it I this time. That is P multiplied by I, give me this. This multiplied by this will give me this. Let's see. So that means P is given, comma, I will say multiply, right? That is, this is the sign of multiply. This is what I will print on the left hand side. Then I print I, right? Then what I need to print again is the equal to. After the equal to, I print the multiplication. Multiply by I. What is I? I is a range. That is for I in range. What is the range? Let's say 1 to 13. So remember, this will be here. This means do this action 12 times. Okay. This means you are going to do this 12 times. So I need to indent. If I enter, I want for 1. See? Look at what I did. I want for 1. That means P is 1. This is this. I now, for the first one, it's 1. Then I times 1, we have this. For the second one, remember it's 1 to 12. 1 to 12. For 20. If I want to extend, I can put even 40 here. If I run the same thing, I'll say for 2. So this will provide us what? A timetable when a number is given. Hope this is understood. Thank you for viewing. Write a Python program to get numbers from a given list that are divisible by another number. What it means is, if this is a list of numbers, say 4, 6, 8, 7, 19. You agree with me that 4 is divisible by 2, this is divisible by 2, this is divisible by 2, this is divisible by 2, and this one is not. So if you are asked to find numbers that are divisible by 7, for instance, you agree with me that it's only 7. If 14 is here, for instance, you can say 14 and 7 are the only number that are divisible by 7. So the list will be given by the user, and the user will also give you the number that you want to check against the list. That is, The list will be given. 7 will also be given. So let's read again. Write a Python program to get numbers from a given list. Number from this given list that are divisible by another given number. Another given number, we don't know the number. It depends on the user to give us that number. So how do we do this? So the first thing we need to do is to get a number we want to find what is divisible by. That is, let's say P, for instance, is equals to integer input. We say give a number to find what it can divide. Okay, I will do it like this. Then I enter. So we ask me now, boss. We can't do anything with this now. Okay, that is just that. The next thing I need to do is to get the list from the user. How do we get the list? The list will be I equals to input. They will say, okay, enter a number you want in the list, or press Q to quit. Okay, this is also needed. This will help us to build the list, this list. We are initializing this list so that we'll be putting numbers one after the other. Okay, that means the only way this one will stop, this one, is when it is what? I is equals to Q. That is, if I is equals to Q. But you agree with me that if you run this now, this will only take place once. But we want this to take place as many as possible, unless if the user press Q. And to do that continuous entry, we must use the while loop. So while what? You can say why true. What is true? Why this continue? If it is like this, all you need to do, you stop. So what you should know is that this break is needed most of the time. If you know you are going to use true, try to find a way of ending the loop. So if I put true here now, this true is, as long as this is true, but you can still break it so that it will not be a loop that will go indefinitely. But because I put a while loop here, this needs to be what? All indented. I will put tab so that it can be ordered this. Meaning, these guys will be working as long as this is true, or it will break if it's no longer true. After doing this, if actually the number is not equals to Q, what should we do? I will say any other one. I can say K is equals to int I. Why int I? Remember, I need numbers to come here. This one, get the number from the user. This one, check if what he enter is equals to Q. I need to put this one as a string. Then I will now, if this is not true, then we will continue. I convert this to integer. So the next thing we do now is to put whatever that is coming here inside here. How do you do that? You have to say list, this list dot append. Append what? Append K. I can show you, let's see. Give a number to find what it can divide. I can say 2. What can 2 divide? Okay. This was say enter a number you want in the list, or press Q to quit. The number you want in this list. I say I want 3. See, asking me. I want this, I want this, I want 10, I want 23. Or let's I press Q. If I press Q now, it will break. If I print this list now, for instance, print list. See, these are the number I entered. So I can tell the system here now, print me what? The list. I can put extra to say for this list, which is, let me format, dot format, then I put the list here. See, for this list, what should I do? For n in list, if n percentile p is equals to 0, I want you to print this for me. Print n that I'm picking from this list is divisible by p, or the grant that when I tested it here, the remainder is equals to 0. S, try next time. You can put anything you want to put here. If I run this now, I want to test a list against this particular number, 6. Okay, now give me the list. Quit. See, for this list, okay, for this list, 6 divisible by 6, 12 can be done, 24 can be done, 90 can be done, but 3 cannot. 7 cannot. That is, if you divide 6 by 6, you have 1. If you divide by this, you have what? 2. Okay, let me try another one. I put what do you want to use? I use 2. Then try this. I want all these guys to be in the list. Then Q to quit. Look at what it's saying. This is the list I built when I put all this. I press Q, terminate. 2 is divisible by 2, you agree? 4 can, 6 can, 12 can, all of them can. But 70 cannot. 3 cannot. This is what the question is testing. Hope this understood. Thank you for viewing. Write a Python program to get numbers from a given list that are divisible by another given number. While testing for the divisible, if the Python sees a value above 300, it should avoid it. I want to extend this program we used for the previous challenge. The question says that if the number you are picking from this list, if one of them is above 300, Python should what? Avoid it. This is the testing. We are testing in this location. So that is the first thing we are going to do now. We're going to say if n is greater than 300. Okay, continue. Continue in Python means don't do anything further for that particular value. You can continue for other values. This one will be else if everything still remains the same. Let's run it. What number do you want to use to do the division? Let me say I want to use 2. So let's look at 200, 240, 2, 4, 800, 400. Let's quit. Look at what happened. For 200, Python said it's okay. For 240, says okay. For 2 is okay. For 800, which is actually okay as well, because it's above 300, it continues. Let's enter. Now let's quit. Look at this. 4, okay. For 600, Python what? Continue. Avoid it. Use 8 this time. 8, okay. 10, okay. 20 is okay. 220 is okay. He saw 800. Say, yeah, 800, you're above 300. I can't work with you. Then 16, which is less than. This is what this question want to test how to use continue. Hope this is understood. Thank you for viewing. Write a Python program that accepts 2 input, that's integer, from a user. If the sum of the numbers is between 40 and 60, Python should report this. Otherwise, you print the sum of the 2 numbers. The first is that we are going to get sum. And if you are going to get sum, you have to initialize sum to be 0. That means there's nothing in sum for now. The first thing, it needs input, and the input is integer. That's one number. I will also tell Python to allow another input. I and j should be summed together. Okay? Then I need to check if the sum is between what? That if it's greater than or equals to 40 and sum is less than or equals to 60, Python should print the sum of I and j. Let's run. Okay, so enter a number. I enter 1, I enter 3. See the sum of 1 and 3. Okay, let me use the word is. Okay, I try another one, 4, I try 9, gives me this. Now let me try 20. I'm going to put 22. Somewhere between 40 and 60. Let me even use this one. Exactly this. Is between 40 and 60. Let me run that again. Let me put 24 now. Then I put 23. See? The sum of 24 and 23 is between 40 and 60. Instead of this, you can actually do something somewhere here. Use the range. If sum in range 40 to what? 61. You start from 40, get to 60, but not up to 61. Do this. The same thing. The only difference is this place. If I run this, if I do 23, I do 24. See? Still the same thing. If I do, let's say 10 and 3, see the same thing. Hope this understood. Thank you for viewing. write a Python program to get the number of digits and alphabets in a given set of characters from a user. What it's saying is that if I type this, for instance, the system should tell me that we have 4 alphabets, we have 5 digits. And for instance, if there are characters that are not either alpha, they are not numeric, it should tell me that these are not what alphanumeric. So how do we do that? The first thing we need to do is to have a place we store the digit. I say D for digit. For now, notice there the number of digits. We don't know anything now. For alpha, we don't know anything. Okay. Now we're going to say N is equals to input, enter a set of characters. So this is a place that the user will put something for me. Then I need to test what he put. Assume the user gives me something like this. I need to use the for loop. The for loop will take this one first, check it, take this, check it, take this, check it, take this, check it. Because it's going to test each of the characters. We say for I in N. Remember, N is the given character. Each of the character will be I. Okay? Do the testing. If I, the first one you are taking, the second one, the third one, the fourth one from the character, you are testing each of them. If is digit, what should I do? Add it to this place. Add it. To add something to this place, you can either do D equals to D plus 1, or you simply say D plus then 1. Using the shorthand. If it's alpha, add it to this place. Say ends. Assume is heart, hash, $, asterisk. These are what? Non-alphanumeric. What should you do? Then I have to go out of the loop and print. Now let's see. If I enter now, as do something like this, let's see. Say what? This is 7 alphabets, 0 digit. That is 1, 2, 3, 4, 5, 6, 7. Okay, let's run another one. Let's put this. See, it's tested per 1. This is what I gave the system. It take this one and say it's not alphanumeric. It's not alphanumeric. It's not alphanumeric. Just like that. See, this is total 0 alphabet and 0 digit. Okay. Now let me try another one. Put digit. Put non-alphanumeric. I put alphanumeric. Then I enter. See, it check all this. This is the location it find non-alphanumeric. So he reported this as we directed it to do here. Then continue with the rest. All this one continue. So we have what? 1, 2, 3, 4. 4 digits. There's 6 alphabets. 1, 2, 3, 4, 5, 6. Hope this is understood. Thank you for viewing. Write a Python program to find the sum and average in float of numbers given by a user. The program stops accepting input if 0 is entered. What it's saying is that a user can decide to enter numbers of input. It can be 67, 8, 9, just continue to accept. But once the user enters 0, the program stops collecting input. Then the program will sum everything together, divide by the number of input entered to get the mean, that is it, to get the average. So the first thing we are going to check now, since we are going to get the sum, let's initialize the sum. For now, there's nothing at the sum, that is 0 for now. Okay. Then we also need to initialize the denominator, that is the number of elements or the number of inputs that will be imputed by the user. And you agree with me if I say 4 divided by 0 is going to be what? Infinite. It's not possible. If I enter this, okay, so because of that, we don't want this type of situation. So to initialize the denominator we are going to use, that is the number of input, let's start from 0, we start from 1. Okay. Later we are going to remove this one by subtracting 1 from 1, or 1 from the number of input. Then the next thing we need to do now is to get input from the user. Because the result will come in float, let's use float instead of integer. We say, okay, enter. See? So we can accept input. The reason why you only accept one input here now, as you can see, let me try again, let me show you. It's 1, see? Just only 1. How can we make this to continue to accept input? That's why we need the while loop. I don't know what to put here for now. So what I will do, I'll just say while true. Remember, this thing will always be true. So I will what? Indent this. This will always be true. But we should be able to break out from this loop. If we continue like this thing will continue forever, unless you press what? 0. Because we have said unless it presses 0, then we have to use that information to break out of this loop. Hence, we say if n is equals to 0, break out. So with this now, this will stop. Without this, it will not stop. Hence, continue what we want, which is if the person enter a value, you increase this I, which is the denominator, by 1. And to do that, we simply do this equals to 1. I've actually explained this. Therefore, the sum also increase it by what? For the sum, also increase it by the value that is entered here. If I have 4, 7, 8 to find the average, I will add them together, divide by 3. That is 1, 2, 3. If I have like 4, 3, 4, 1, 7, 8, I will add all of them together and count the number of them. 1, 2, 3, 4, 5, 6. Divide by 6. So this is what I refer to as I, which is the denominator. That is I. And to get it, like for instance, if the user enter this 4, it will add 1 here. It's counting the number of these guys that are entered for I. So if we succeed in doing this, the next thing we need to do now is to find the average. So the average is equals to sum divided by I. Remember, I has 1 here already, which is what we use to initialize it, and it's coming from nowhere, so we need to remove it to recognize that what is not needed. The next is to print the values. See, we get the sum, also get what? The average for us. Let's put 1, put 2, put 4, put this. We put so many things now. Am I okay? I'm okay now. Put this. See what I put? But this is the sum. This is the average. If we also want to know the number of elements, we can also say print I minus 1. So if I enter 2, enter 4, enter 2, you agree with me that this is 8. Let me make it plus another 4. You agree with me that now we have 12. 12 divided by 4 is 3. So I enter 0 to terminate. So altogether, I say I have 10 items entered. So I enter 1, I enter 3, I enter 4, then I enter 12. If I enter 0, you see it's 59 divided by 3.9. Let me even put here, just a sum is this. Say average, put a comma here, I enter again, put 0, terminate. See, this is the sum of all these values. If we look for the mean, we have this as the mean. And you can see they are coming in float. Because the question says all this should come in float. Hope this is understood. Thank you for viewing. What is function? A function is a block of code. Designed for what? A specific task. Or a group of tasks. You have code packed together, grouped together, brought together to achieve what? A specific task for you. Such a code is called what? Function. We have different type of function. We have the built-in function. This built-in function comes with Python. We are talking about this like min, which we use for minimum, like the mass. If you are looking for maximum number among integers, for instance, you are looking for the length of a string, this len. These are inbuilt. Okay? If you need ep, use ep function. These are inbuilt function. Okay? We also have the user-defined function. User-defined function. For user-defined functions, these are functions created by users for a specific task. In this class, all we're going to do is user-defined function. That is the purpose of this section. To see how you can define your own function. So when you define your own function, this one comes with Python. And if you desire to create your own function, we call such function user-defined function, because you are the user of Python. If you need a specific function or you want to achieve some specific task and you decided to create your own function, such a function is called user-defined function. Okay? The last but not the least, anonymous function. We also call this kind of function lambda. We call it what? Lambda. They are called anonymous because they are not defined with the standard def. Okay? I'm going to explain that to you next. Because when you want to define your function, for instance, you use def to define them. But other displays, you do not use def. That's why we call them anonymous function.
Before we continue, let's look at the inbuilt functions in Python. These are the inbuilt functions. All of them, as you can see. These are all the inbuilt functions in Python. We have seen some of them. For example, we have seen the fuzzy set. Okay. We have seen input. We have seen ID. We have seen len. We have seen mass. We have seen min. And many others we have seen. Like this, we have seen all this. Okay. We have seen this as well. And we are going to treat others like, for instance, this in ticketer. And any other one that is going to be relevant in our course, we are going to treat them. And if you want to know everything, you can easily read them up. They are straightforward. But let's just look at this particular one before we close this inbuilt function.
What is the purpose of its instance function? This is used to test what an object is. For instance, if I have 10, I want to check if it's an integer, I can use its instance, just the way you are seeing it now. If I have 10.5, for instance, or 10.3, I can check if it's a float. Say here is a float. Let's say tuple. I enter. I say, what type of object is T? Is it a float? Is it a tuple? Is it an integer? I can check as well. Put this 3. If one of them is true, this will be true. See, one of them is true because this is a tuple. If I remove this tuple now, you see that it will give me what? False. You can also test like this. What if I do something like this? See, this is a list, for instance. I can add the system. For instance, let me just put another thing like float, false. If I put list here now, it says true. Or I can decide to put this, say list, tuple, dictionary, float. Say what? It's true because list is here. If I remove this list now, you see it's no longer true. But if this was a dictionary, I put, it's true because this is a dictionary. Remember, it's true for dictionary. So let me remove all this other one, just for you to see. It's true. So if you want to know the type of object a particular value is, in Python, simply use what is instance. Hope this is understood. Thank you for viewing. How would you create a function? You are ready to create your own function. What is the first step? The first step is to enter def, def. When Python sees def, it knows that you want to create your own function. After this def, Python expects you to give a name. So you give what? A name. After giving a name to Python, you put what? The curved bracket, then the semicolon. You have to indent for indentation, which is standard in Python. Then you give what? Statements. All these statements are what? Block of what? Codes. It can be 1, it can be 2, it can be 100, any number of statements you want to put. This is a pattern of defining your own function. Now let's see how to do that using Jupyter Notebook. Now look at this. If I tell the system print hello world, this is a code which I'm printing to the screen of my computer. Print means print this on the screen of the system. Okay. Now let's use this one to do a function def. Let me say the name of this is hello. Okay. Then I give what? Semicolon. I enter. You can see what? We have forward indentation here. Then we put, I just want to copy this. Remember I told you earlier that whatever you are putting here are the codes. Then I run this. Shift enter. The next thing I want to do now, if I want to call this function now, if I want to see what is in this function, I will call this guy. Okay. Copy the guy. then place here. If I run this now, you see we have hello world. What is not the difference? By just putting this now, I have hello world. If I increase anything here now, hello world, my name is Python. If I update this now, when I run this, I have what? Hello, my name is Python. Now let me also show you something. If I copy this, for instance, I put V here. I say this is equals to V. If I put V now, let's see what is V. See? V, hello world, my name is Python. Now let's look at this. What I want you to know is that function is like a bag. Function. It's like what? It's like a bag. Okay? Whatever you put in here, whenever you want to call it, you give the name of what? Of this bag. For instance, I call this bag hello. What did I put inside? I put hello world. My name is Python. That is what is inside here. Hello world. Then I tie it up by running it. Anytime I want to get this information, the only thing I need to do is to call this guy hello. Whatever name you gave to this bag, just use that name to call the function. This is what I want you to know. I don't know if you understand that. Let me show you again. As I just said, I said, for instance, you have a bag. Instead of putting coins, you put hello world. My name is Python. Then you call it any name you want. And the name we gave to this one is what? Hello. So whenever you want to get this information, all you need to do, just put hello. The system will bring this information out for you. Then I also try by putting this same information in a variable. Then I put this here. What I put it, when I wanted to get this, I just put a variable. It gave me this information. So what is the difference? For variable, it's just a placeholder, the place you put things. But with function, you can do many things. Function will allow you some time, if you want, to put your inputs in between this place. By say, for instance, say hello. I can put anything I want to put in between here. Such a thing I'm putting here is called what? The parameter. Okay? So if I need to update this place now that once to give a name, you can put parameter here, or you decide not to put parameter. So whenever I want to call this name today, or I want to call this function today, it's a matter of what? Giving the input in place of what I define to be in this place. Okay? This might be a little confusing if this is the first time of you doing function, but just be patient. It's going to make a lot of meaning to you very soon. If you have something like this, we call this one the header. This is what? The body. Header and body. So we can have a lot of code inside this body, as many as you want. We are going to see many of these as time goes on. What is the purpose of return in Python function? As I said, if you want to define a function, you say def, you give the name of the function. If there is input, you put the parameter, then you put your statement. As I said, this statement could be 1, 2, 3, 4, or several of them. What is the purpose of return? Assume I have this kind of function. Once the system sees return, it will stop executing statement after this return. Assume there are statements here. There's another statement here. Once Python sees return, it means stop executing the statement under this function. Okay? And also, what you should know is that if a function, let's say function 1, okay? We have another function 2. If this function has return, it will have something to return. That means it's meant to return something where you call this function. If this one has no return, it's not going to what? Return anything where you call this function. Let me show you. For instance, if I say def, let me give a name. Let me say the name is u. Then I go further to say return 2 multiplied by 2. Okay? Then I enter. If I call this function now, u, I have what 4. Remember, it's giving me this one 4. That is 2 times 2. When you call this one, you say what is this? What if I go further to say, this time, I'm going to say u2, then I put 3 multiplied by 3. Then I run. If I put u2 now, you see, notice return to me. So the return helps the system to know if you expect me to return a value where you call me. Okay? When you call me, do you want me to return a value? Do you want me to return anything? That's one of the purposes of this. Now let me go further to say, now return is coming before this statement. And I told you that once the system sees return, it means that don't do anything again anymore. Now let me run this. I see. If I run this, I call U3. You see? Notice return. Because this function is not saying this. The execution of code ends here. You see? Two purpose of return now. To return something and to tell the function when to stop. For instance, I say def x. I want S1 and S2. What do I want to do? S1 multiplied by S2. Okay? Then I enter. So if I want to call this now, then if I want to call this, I will put something here. Let's say I put 6. Here I put 6 to make it easier. That is 6 multiplied by 6. So this guy is inserted here. Why this guy is inserted here? Let me just make this one 2. If we run this now, we have 12 because we tell the system to return this. Okay? What if we just go ahead with this now? It's okay now. We're going to have S3 here, but this time, let's call this one multiplication. This time, I'm not going to put return. I'm simply going to do times S3. Then I run. Now, I want to call this guy. I will put 3 here, put 2 here, put 2 here. You agree with me that normally this should give us what? 12 if we run. If we run and notice return. Why? Because there is no return here. We are telling the system not to return anything, but don't give me an error. What if we say t is equals to this? We now say, okay, what type of data is this? Non-type. Non-type means I don't know the meaning of this. Okay? What if I also add the system to tell me what s is s? Let's go back to this place now. Let's just say u is equals to this. If I run this, if I put u here now, it tells me u is 12. If I say what type of data is u, I say type u. Let's see. Now int. Remember here, I asked the same question. What type of data is t? Say not type because I did not return anything. I did not return integer. I did not return string. I did not return a bool. I did not return anything. So it says it's a non-type. Return is 1. To return you a value and also to tell function when to stop. Show me how to use parameters in function. What is parameter? Parameter is, if you say def, for instance, you say y, then you put this before you put your statement. Whatever you will put in between this curved bracket is called what? Parameter. And what is the purpose of this parameter? Let me explain to you. If this is orange, you agree with me that when you go by orange, all you just need to do is to call the orange, you find something inside, then you suck. Simple as ABC. You don't need to add anything to the orange while this is here. All we know is that once it's an orange, just by peel and eat. Something's already on the inside. Okay? But if you have a machine, let's say blender, some other thing, let's say this is a blender, you are expected to put your items here. The blender is meant to blend it. After blending it, you can pour it out. So we are going to call this place the input. Then what you are pouring out from this place, after you finish blending, let's call it what? The output. Parameter is your input. Okay? Why this one is what you are returning? The output. So this parameter gives you opportunity to decide what you want whoever that will use this function to impute. In case of this orange scenario, you are not expected what to put any what input. It means you are going to make this place what just as it is. Don't put anything here. This like the orange scenario. You are not putting anything. But if you are going to put something in between this, for instance, say y1, y2, that means you are expecting somebody to put input. This is what the blender scenario. It's like a machine. Let me show you. It's like a machine. Then this is where you put the input. This is the output. This is a processor. So the processor is your function. This is your parameter. This is your return. Okay? Now let's give a scenario. What is the area of a square? What is the area of a square? The area of a square is simply what? Any of the side raised to power 2. That is to say, if this is a square, we expect this to be equal to this side. Okay? That means we have 2 here, 2 must be here, 2 must be here, 2 must be here. So the area is equal to 2 multiplied by 2, which is 4. Now let's create a function that will help us do this. Let's define a function. Say def area underscore square. Area of a square is one input. Any number you give is expected what? To be squared. Then we enter, say return s multiplied by x. That's a square. Okay? Then we run. I want you to watch this parameter. Now I'm going to call this one with anything. I'll say area 1 is equals to this. Okay? Let's replace this one with 3. Then we run. If we put area 1 now, we have 9. Okay? Let's go further to replace this one too. Let's call it what? Area 2. Let's put 5.5. If we run this, if we call this guy, we have what? 30.25. What are we doing? This parameter gave us opportunity to put 3 here, to also put 5.5. You can put any value. Once we put the value, the system is meant what? To multiply. I put the result here. Okay? But remember, if I go direct, for instance, I just copy this direct. If I put 10 here, it's giving me 100. This is returned, okay, from this place. 10 multiplied by 10. If you are not using Jupyter Notebook, you may have to put your print to see your result. This print is just for you to see what it's doing, just to print on the screen. But what is returning is what is important, okay? For instance, to let you know how powerful this is, if I take this again, I say this time I want to put 4. Remember I will get 16, right? I say multiply by 10. I should have 160. Let's run. See? 160. This alone is something you can work with. You can work with this because there is return inside. What if I say, okay, def, let me just take anything for, let me say num. I simply put, let's say I. Then I put I multiply by 2. I desire to print this, just to print. I say print I multiply by 2. I am not returning anything, okay? Now let me run this. If I come here, for instance, I say go for num. In place of I, put 3. Let's run 6. Why is it giving us 6? It's giving us 6 because I put print here. It's not returning anything. It's not returning anything. For instance, if I call this guy, say type this. If I run this, it says it's a non-type. Why non-type? Because I'm not returning anything. This since you are seeing here returned is different from this 100, is different from this 30.25 because this is returned. This is something that is tangible. It's like you have a television, you are watching a program on your TV, okay? You see a man on the TV. You can't touch the man. He's just printing image on the screen of your television. You can't touch. You can't use it. You can't reuse it. But I wish this person is standing before you. You can send this person an errand. You can ask him a question. You can do many things with this person. That is the same thing with this. This print you are seeing here is like what you are seeing on the television. Like this one we use return. That is why we are able to say this that is tangible multiply by this. Now let me now go further now to say, okay, now I know that num you gave us 3, okay? Let me multiply this by 10 as well. I should have what? 2 times 3 gave us 6 here. I should have what? 60, okay? The same way I had when I put 4 here, 4 times 4, we have 16. Then we multiply by 10, we have 160. This one should also help us because we have said I multiply by 2. It means that 3 multiplied by 2 give us 6. Multiply by 10 should give us 60. But it's going to give us error. Okay, if we run this now, it's going to give us error. Unexpected operand. This, not type and int. You see? Why is it calling not type? Remember, if you want to multiply to integer, it must be integer. But this time, I'm using a not type. Why is it calling it a not type? Because this not type is because there is no return here. This is just picture. This is just picture. You cannot treat picture as an object or something that is tangible. But if I had put a return here now, for instance, let me rerun this. If I'm not using Jupyter Notebook, I should put print here, but Jupyter Notebook is helping me to put print behind the scene. Okay, good. Then if I ask for the type of data, it says what? It's what? When I run this, it says now integer, no longer what? Not type. If I multiply it now, this error will disappear. It's now giving me 60 because I put return here. This is something I can reuse, something I can use. But we just print. You are only seeing something on the screen. With return, it means it is not tangible. It's a tangible object you can use any other place. Okay? So please know that this parameter, which is actually the aim of this class, is to give you opportunity to impute something into what? The function. To give function some information to use. But if this wasn't here, it means it's like orange, which is something like this. What I mean by orange is something like this. If I say def, let me say calculate. Notice here, I just say print, as I said, Mr. Man. If I call this guy now, there's something already living inside. It doesn't require my input. It's just going to print it for me. Okay? Or even though I don't put this here, let me just put another thing here so that you not be confused with the print. I said return 9 multiplied by 10, which is what? 90. If I run this now, if I click this, it's giving me 90. Why? Because this guy doesn't require any input from me. There's something already living on the inside that doesn't require my input. Okay? But for this guy that has something to input here, the parameter is giving you opportunity to put whatever input you want to put. For this guy, without anything here, it means it's like orange. There's juice on the inside that doesn't require any processing. But if you want something to be processed for you, simply put the parameter. Hope this is understood. Thank you for joining.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
What is flow of execution? Flow of execution. As you can see, in this arrangement, we have this first, type. Before we type this, before this was typed. If you're going to read this program the way it is typed, you're going to have what? Mistakes. What is the best way? The best way is to follow what? How the system will execute this program. Let me show you what I mean. If I run this now, okay, now I want to call F1. Look at it. When I call F1, the expectation is this should come first, followed by this, then followed by this. You can see what it did. It did the second one first, which is this one. Although I did not call this guy, then printed this before what? Before it printed this one. That's why when you are reading a program, look at the flow of execution, not the way it is typed. Why is the system behaving like this? Let me show you. As you can see, I had the system to call this guy. When he called this guy, he found out the first that was here was what? Third. So he went to third. On arrival in third, he also found that this third, the first thing that was there was second. He came back to second. This is the first thing that is here. That's why it's printed this now as the number one thing. I am second. You can see I am second is the first thing that was printed. Remember, this guy has this guy to come here. On coming here, he printed this. He needs to finish it because the system says go for third first. When you finish with third, when you finish with this third before you come back. So this is done, which is this. Then this needs to be printed. That's why you see that this was the second thing that was printed. When he finished with this one, before he came back to print this one, the system wants this. Call this guy. When he called this guy, this was the first thing. So he needs to finish with third. Come for third now. He found that third has second. He printed this for it. He came back to print this. When he finished with third, he came back here to print this. This is called what? Flow of execution. This is what you should be looking at when you are looking at a program, not the way it is typed. That is why you are seeing this result like this. See, the second was printed first, followed by third, then followed by what? The first. All this is understood. Thank you for viewing. What is the difference between encapsulation and generalization? I gave you an instance of orange today, saying once orange has what it has on the inside, you don't need to put anything. All you need to do is to open and eat. For generalization, it's when you have to give a room for input so that the function can process the input to produce an output. This is generalization, while this is what? Encapsulation. Let me show you with instance. If I say, for instance, S is equals to 100, I say Y is equals to, let's say 10. If I say S divided by Y, you see, we have what? 10. I can do this one, encapsulate it in a function by say def, let me say div. That means I want to divide, then I put this. Because it's a function now, I move this here, then I say return this. If I run this now, then if I call this to be giving me what? 10. This encapsulation. I can only run this one once, and there is no room for input. We call this one what? Encapsulation. But what if I want to give room for the user to put anything for S and Y? Let's say only X. We can remove S from here now. We put S here. What I'm doing now, I'm generalized. Why do I call it generalized? Because when I say generalized, it means that anybody can decide to put whatever input he wants to put. You want to put 20, you want to put 30, you want to put 100, you want to put 25. You can put anything. That's what generalization. Anybody can use it. But if I don't give this room, there's no way to impute anything. It is called what? Encapsulation. So let's see this generalization. I see how it goes. If we run this again, if we run this now, see, it's giving me what? Error. Require positional argument X. That means I need to give it S. What should be S now? Let's put 200. I can put 200. If I put 200, I have what? I have 20. If I come down here, I put 1000. I have 100. So you see, this is generalizing this function because it is giving you opportunity to what? Impute anything for what? For X. But before now, when this S was not giving us room to change the value, we say what? This is called what? Encapsulation. Something like this. But if you are going to give room, even though if you remove the 2, I call it X, Y. This is generalization. But if you are not going to give it a room to impute anything, we say what is encapsulation. All this sort of too. Thank you for viewing. What is default value for argument when defining a function? Let's see. If you say def, you say function. For instance, you put A. You say print A. You enter. If I say font 1 or let's say 12, the system print 12. What if I do like this? A font, this is giving me what? Error. Say missing one requirement positional argument A. But while I was defining this, if I was proactive, I said, okay, in case the user did not give you any input or whatever, use 199. If I do the same thing, I'll say font, run. See, 199. This is default. This now is the default. But if I go ahead, I still give this function an argument like 12 or any number, let's say 129, it will still print 129. But this default value now is telling Python that in case the user does not give any value for A, use 199 for it. So this is how to define what? Default value for argument. Okay? Let's see another thing. For instance, I want to multiply two numbers. So I design a function, I say function 2. What you're going to help me do is A and B. But B should take 10. Okay? I enter. I say what you need to do, return for me A multiplied by B. If I come to say font 2, I put only 2 now. Remember, if I put 2, A will collect it. A will receive it. But there is nothing for B from me. So the system will use the default 10 to work with it. It means if I print this now, I will have 20. How is it 20? This 2 multiplied by 10. Okay, let me go further to put two values here now. 3 and 4. Now look at what will happen now. It's not 12. That means the system discard what? The default. What this means is that in case the user don't give you any input or argument, please use 10. If he gives, use what he gives to you. I gave 4, he used the 4 for me. If I had not given 4, assume I just did this, simply put, let's say, only 3, for instance, it will multiply by the default, which is 10. Hope this is understood. Thank you for viewing. Write a Python program to print the name of a student and the age of the student. If the age is not given, write above 18, okay? We write this, we say student. We want the name, we also want the age. In case the age is not given, we should write above 18. Because see, this is the default. So the next thing I'm going to do now is simply do this. I say print the name of the student is, or simply write name, comma, is age. I just put this one small letter. If I run this now, then I come to say student. I give first, let's say I give Peter. Then I give 18. Say Peter is 18. What if I give something like Andrew, but there is no age? See, Andrew is above 18. You see, this is the default. Above 18 is the default. So this default is helping the system in case the user forget to put the age, use this statement above 18. All this is understood. Thank you for viewing. Write a function to take 2 inputs. The first input should be any length of a string, while the second input should be a letter. The work of the function is to count the number of the letters in the string. The given string or letter could either be lowercase or uppercase. What are we saying? You have a function, for instance, let's call it count. The first input should be what? A string. The here will be a letter. I call this one I, for instance. I call this one this. That is how many I in this. That is only 1. It will return 1. If this guy is capital letter, it doesn't matter. You should still count it. Assume I write something like this now. Let me say hello world. So the letter is, for instance, let's say O. How many O here? We have 2. But assume that the O that I gave was capital letter O. You still give me what? 2. This is what it's saying. The first thing is that you take 2 input. Let me call it count. I will call the first one word. Then I say the second one is a letter. Okay. Then the next thing I want to do now, I need to count. So let me initialize this. You can put anything here. This is what I will use to return the number of this letter in this string. I will say for I in word dot lower. What am I doing? For I, that is for I will take whatever that is given to me here. I will be iterating through each of the letter in the string. I will say if I is equals to the letter, then convert to lower. I will update this place now by adding 1 to it. Then I will return the total. Okay. Let me run this first. Then I will come back to explain to you. So if I take count now, for instance, let's say I put here, this is lovely. I want to count the number of I in this place. I will simply say I. If I run this, I have 2. That means we have 1, 2. What if this was a capital letter? Can you see count? Same. Okay, let's use this time. This is a lovely program. Let's put capital letter O here. Say there are 2. What if we put G, capital letter G? Say it is 1. Okay, let's see. The first thing we did is to declare a function. We initialize where we want to put the count because we want to count. It's like you are creating an empty box. You want to be dropping what to count. Okay, so we say for I in words. That means this is a word here now. For I in word, that means this means you have to iterate through this. You understand this if you have not jumped any of the classes we have treated before this. This T, for instance, is the first T that to be picked from this place, then to be converted to lower. After converting to lower, this one is checking it now. Is it equals to the letter that is here, that is this G? But then you have to convert the G to lower too, because this one now is already converted to lower. So lower and lower, okay? Then if actually it is equal to this, therefore increase this total by 1. That is the meaning of this. Assume when it gets here now G, if find all those one, none of them, until it gets to this place, you upgrade this one by 1. If there was another G here now, when it gets there, increase it by 2. That is the meaning of this one, okay? Let me just show you. If I put G here now, another G, small g, another G, or big G, small g. Now let me run again. You see, store this one, 1, 2, 3, 4, 5, 6. Okay? Hope you understand it. Is it possible to assign a name to a function and call it through another name? If yes, demonstrate. Yes, it is possible. How do I mean? This is a function. Def, let's say run. This is the name of this function. What I want this function to do for me is to run through, say, some variable. For instance, let's say A. Then I will say for I in A, okay, print I. The next thing I want to do now is to call this function run. To call it, I can do something like this. Simply say U equals to run. Remember the name was what? Run. And there is nothing like this curve bracket. Understand? This is a different name now, U. And I want to put these values, say 4, and I ask the system to run through for me. You see, it ran through and gave me all this. What happened? This was the name I used to define the function, but I'm now using U to call it because I assigned this run to a variable U, and I can use this to call it. Let me show you another one. What if I wanted to say def school S-R-Y print, or let me say return S-R-Y, not the S. Enter. I say name is equals to school. See, I say name now. The first school I have is IQ school. The next one is Python school. I enter. See, I'm calling this school now with a different name that's not part of this function by assigning the name of this function to this name, just a variable. Now you can see curve bracket here, which is not anywhere to be found here. It's now what? Part of this name. And this output is returned without any error. So therefore it is possible to call a function with another name if you follow this process. Hope this is understood. Thank you for viewing. Write a function that helps select out words from a sentence that are longer than a given number. Assume this is a sentence you are given, and you are given 4. So, okay, select out from this sentence words that are longer than 4. That's what it's saying. To do that, we define the function. Let's say words. Say the given number, let's call it A. The words will be handled by W. We say, okay, the first thing we need to do for this is to be able to separate the sentence. W.split. Okay. Then I tell the system I should split it. I need to put this particular splitted sentence in a location. Let's call that location D. The next thing we need to go through D. That is to loop through. So for I in D, what do you want to do? If I is greater than A, if I is greater than A, that is this number given to you, we have to put that particular word in a place where we find them. So to do that, let's say final, for instance, the final place to locate them, or let's say sorted or sorted underscore words. Anything you want to put. To do that now, we have to say append what you are getting from here that are more than this A, append them in this place. This dot append I. After that, all you need to do, you return these sorted words. That is all. Then we run. If we pick this one now, we say print this for us. But I want words that are more than, let's say 4, 5, whatever. let's say 4 from this sentence. Then I enter. We miss something. This place, we are using to compare what? We say for I in D, if I is greater than A. Remember here now, A is a number. We can't do it like this. We have to use what? Length. The length of what? Of what you fetch from this place. If the length is more than A, that is a given number like 4, before you do that, you can see the error say this not supported between instance of string and integer. As you can see here, we have before I, which is what? A string. This is what? Integer. As you can see 4. So with this line now, looking for the length of I, both of them are now in what? In integer. If we run again, then we run this one again. We have all this from here that are more than what? 4. Okay, let's try another one. I run this now. Let me put 2 here. Then let's run this one again with 2. See? These are the what? Words that are more than 2 in this place. If I run this one now, this time I'm going to put, let's just put 5. If I run now, only 2 words that are what? Longer than 5. All this is understood. Thank you for viewing. Write a Python function to get unique elements from a list. This means write a Python function to remove what? Duplicates. We want to remove duplicates from a list. Okay, let's say def, let's say unique. Okay, then put a list. The first thing we need to do is to design a place. Let's say D equals to this. A place will be putting the unique elements. The next thing we need to do is to say we need to loop through the list. While looping through, we need to find if not I in D. Okay? D dot append I. The only reason why you should append it is because it's not already in D. This is to loop. Get them one after the other. Give me the first one. Check if this particular one is already in this place. If it is not there, append it. If it is already there, you can't do anything because there's no room for that. If what you are giving me now is already at D, you can't do anything. Just ignore. Okay? Then I can close now to say return D. If I run now to say print unique, what am I printing? I want to get the list of this, remove all the duplicate. I want this state element. Let's run this. You see that all the duplicates, such as here you have 4, here you have 4, we pick only 1. Like this 5 that is duplicate, we take only 5. Like 6 that is duplicate, we took only 1 6, 7, only 1 7, and so on and so forth. Hope this is understood. Thank you for viewing. Write a Python function to merge any 2 given dictionaries. Look at this. These are 2 dictionaries. Dictionary X, dictionary Y. We say we define a function that can accept 2 parameters. We say, okay, this is a new variable, and this variable, whatever that is at A, look at this. The first thing I will do, let me remove this. Okay, look at this. We define a function, we call this one merge, that accept 2 inputs. We define a separate variable. The variable is to copy whatever that is at A into D. After you have done that, that is, for instance, copy whatever that is here into D. Once you have done that, update D by B. You understand? A and B are given. We say this is a new variable. Whatever that is at A, copy it to D. Once you have finished copying, we still need the information at B to be given to D. Update it now. Once you update, it will now extend it. That means at the end of this one, this will continue from the end. Continue from here. Let me show you. Look at this. 1, 2, 2, 3, 3, 4. 5, 2, 4, 5, 6, 8. Then we return what? D. If I run this, for instance, see what I have? This hence here, this guy continue from this place. Then stop here. See what I've done? The first thing I did was to first of all get a new variable, which is D. This D, first of all, copy what is here to D. Then if you want to update D now, simply what? Update it with what? Y. Look at it. We gave the input, 2 inputs, copy A to D, then update D by B. Then return the D. This is how to what? Merge any two given what? Dictionary. Okay? For instance, I can do it direct without even going through the process of assigning this dictionary to any variable. If I run this now, I still have the same solution without any error. All this understood. Thank you for viewing. Okay, it says we should write a Python program to do what? To add these numbers. This is just a sample. It could have been any number or list of numbers. That is to add any list. Could have been 20 numbers, 100 numbers, a billion numbers. Any number of numbers. This is the solution. Let me explain. This is a function we define for this course. This is the place we'll be putting the elements, the numbers that will be given to us. And this place, I'm telling the system that I want to add things together. So I define an empty container. Say total. At start, it was 0, empty. This for loop, that's okay. If you are given any number, just as they give you here now, loop through each of them. Using this one as instance. First, for each in element, remember this element now, this whole thing here is representing this. Okay? Therefore, when you are looping through each of them, you can put anything here. You can say me, you, but I use each for easy understanding. And these elements are everything here corresponding with this. For each, go down, add them together. That means this is the total container. This one may put them inside the container, put them inside the container, put each of them inside the container. So when I take the first one, each, which is this, I will go and put it in the container. As at now is 4. Then I go again for each. I go for this. When I come here now, I will meet 4 here. Before it was 0, now it's 4. The 4 that is here now, we add this 6 to it to become what? 10. I come back again, I see minus 9. I put it here. 10 minus 9 become 1. I go back again, I take 5. I add 5 to this, becomes what? 6. Just loop it through each of them. You know return? How to return a function. Then this is just to call to print. Okay? And if we run this now, we have 6. See? We loop through each of them. You can use this one for any length of number. Whatever you want to put here, you can use it. Add, you have this. Any numbers. Looping, adding each of them. Hope this was informative. Thank you for viewing. What is nested or inner function? What is nested or inner function? An inner function is a function in another function. A function that is what? Encapsulated in another function. You have an outer function. There is another function inside this outer function. This is the outer. This is the what? Inner. How do I mean? For instance, you say def, you say outer. This is the outer function. Then you put your parameter, such as you can say A. Okay? Then you go down, define another function now inside this outer function. Let's call this one inner. This inner, we are going to call it, let's use A for it, so that whatever we pass to this guy will be used by this guy. Then let's work on this. Let's just tell the system to return A. Return A. Maybe A multiplied by 2. Okay, whatever you want to do here, you can do with A. But what I want to show now is, this is what? The inner function that is encapsulated in this outer function. So the next thing is that, how are you going to access this inner function? To access it now, you can declare a variable. Let's say variable for inner. Let's just do it like this. Equals to this function. Once you have done this now we cannot print this, which represent this inner function. We can also print this, which is what will be supplied the outer function. Okay, let's print A, then we print in. Okay, we enter. Let's now test it now. If we say outer, then we put 3 for instance. So we run this. Now let's call the outer. Let's say outer. Let's just put 3. You see, we are having what? 3 and 6. 3 being the value we supply, which is A, and which is here. And this, which is 6, is from what? The inner, which is A times 2. That is 3 times 2, giving us 6. Okay? So this is how to define. So we refer to this one as inner function, while we refer to this as what? The outer function. We say this is encapsulated inside this what? Outer function. Hope this is understood. Thank you for viewing. Take a look at the two sets of codes below and explain what is going on in each. That is, this particular code and this other code. Okay, as you can see in this place, we define an outer code. Please listen very well. As you can see in this place, we define an outer code with 2 arguments or 2 parameters. Then we define an inner code with 1 parameter. But this inner code is going to process them like this by multiplying what is coming from the outer code with the inner code. Okay, this inner code ends here. But this outer code has to return something. Instead of this outer code to return any other thing, it returns the what? The inner code. You can see, it returns what? The inner. This is the inner code returned by the outer code. Remember, this return is for this, while this is for this. Okay? Now, the next thing is that we want to call this outer code now. We call the outer code with A, with these 2 inputs. You are not still true because as far as this is concerned, only this and this, what we have now. We don't have Z. To finalize it, we give 10 for this. Remember, this A represents outer. Outer has already accepted or received its input. These 2 input. But this inner has no input yet. So whatever you are giving to A now, will be given to the inner. If I run this now, I have what? 60. That is to say, 2 times 3 give you 6, times 10 give you what? 60. To confirm that this 10 is actually for Z, let me enter. Without anything here. Let's see the error. Look at this error. Inner missing 1 require positional argument for Z. See, whatever that was here was actually for Z. Okay, let's put this 10 back. Let's remove this to see the error it will give to us now. Let's just put only 1. Let's run it again. Let's see the error. It's not complaining of what? Y. Where is Y located? Here. As you can see, this one, as I said, is for display. And whatever you are going to give to this guy, where you want to print it finally, is for Z. Okay? Remember, this guy ends here. This is his return. This return is for this guy. But it's returning the inner. Because it's returning the inner, whatever you are going to pass to this guy is for the inner. That is the reason why we have this 10 for this Z, because you are returning the inner. Now let's continue. The same thing goes for this. The difference between this and this is this one, the outer is receiving 1 input, or call it argument, parameter. The inner is taking 2. Okay, this guy, which is for the outer, still returns what? The inner function. What we put for outer now is for this A. We house it in where? We house it at X. S is the variable that is house this guy. If you give argument to X, because S now, which is for this, for all of them. Remember, outer is capturing all of them. How do I mean? This is the what? Outer. This is the inner. Whatever you give to this outer to be given to A, that's the first one. Then what you give this to, this outer will be supplied what? We pass them to what? To the inner. Because this S now, which is accommodating outer, is actually what? Housing also what? The inner. Okay? If you run this now, you have this. We can generate something. Let's just define something by ourselves. Say def. Okay? Let's say calculate something for us. What are you calculating? Calculate A and B. Once you calculate A and B, what do you want me to do with them? I also want you to define for me, let's say, sum. What are you summing? I want to sum something for X and Y. Then we come to this place now. Okay? Then return. What are you returning? We want you to return X multiply by A. Okay? Divide by B minus Y. I'm just doing something just to show you you can do anything you want to do. What I've done now, 2 input will be supplied to this guy. 1 is taken by this. 1 is taken by this. Remaining these guys. Okay? Remember, I've returned for this inner. This is for inner. I've returned for this inner. This is for the inner. But what for the outer? Outer will return for us now. Sum. We return sum. Okay? Ends there. No need to pull this. Okay? Once you have done that, if you want to call the outer now, let's say we call outer with D equals to Cal. we put two values because of these guys. Let's put now, for A, let's put 10. Then for B, let's put 20, okay? If we come in as a print D, I mean this D, if we give two value to this D now, these two value will be for what? These guys. Remember this ones is for these guys. Any two value you put here now goes for this guy. But before we do that, let's put just one value here. That is for X. If we put like 5 here now, it will give us error. See? 1 is still missing because we have not finished supplying it everything. Okay? So this is for S. Say comma, we put something like 2. We run now, we have our output. So you see? That's to say, as far as this is concerned, this is S. S is here, that is 5. Multiply by, this is A and this is A, 10. Divide by B. What is B? B is 20 minus Y. What is Y? Y is 2. It's equals to 50 divided by 18. And if you check it up, 50 divided by 18, 50 divided by 18, we have this. The same thing with this. Hope this is understood. Thank you for viewing. Take a look at the two sets of codes below and explain what is going on in each. That is, this particular code and this other code. Okay, as you can see in this place, we define an outer code. Please listen very well. As you can see in this place, we define an outer code with two arguments or two parameters. Then we define an inner code with one parameter. But this inner code is going to process them like this by multiplying what is coming from the outer code with the inner code. Okay, this inner code ends here. But this outer code has to return something. Instead of this outer code to return any other thing, it returns the what? The inner code. You can see, it returns what? The inner. This is the inner code returned by the outer code. Remember, this return is for this, while this is for this. Okay? Now, the next thing is that we want to call this outer code now. We call the outer code with A, with these two inputs. You are not still true because as far as this is concerned, only this and this, what we have now. We don't have Z. To finalize it, we give 10 for this. Remember, this A represents outer. Outer has already accepted or received its input. These two input. But this inner has no input yet. So whatever you are giving to A now, will be given to the inner. If I run this now, I have what 60. That is to say, 2 times 3 give you 6, times 10 give you what? 60. To confirm that this 10 is actually for Z, let me enter. Without anything here. Let's see the error. Look at this error. Inner missing one required positional argument for Z. See, whatever that was here was actually for Z. Okay, let's put this 10 back. Let's remove this to see the error it will give to us now. Let's just put only one. Let's run it again. Let's see the error. It's not complaining of what Y. Where is Y located? Here. As you can see, this one, as I said, is for display. And whatever you are going to give to this guy, where you want to print it finally, is for Z. Okay? Remember, this guy ends here. This is his return. This return is for this guy. But it's returning the inner. Because it's returning the inner, whatever you are going to pass to this guy is for the inner. That is the reason why we have this 10 for this Z, because you are returning the inner. Now let's continue. The same thing goes for this. The difference between this and this is this one, the outer is receiving one input, or call it argument, parameter. The inner is taking 2. Okay, this guy, which is for the outer, still returns what? The inner function. What we put for outer now is for this A. We house it in where? We house it at X. S is the variable that is housing this guy. If you give argument to X, because S now, which is for this, for all of them. Remember, outer is capturing all of them. How do I mean? This is the what? Outer. This is the inner. Now, whatever you give to inner first, inner will accept it. That is A. If you give to extra, to whatever you are using to house inner, we call inner S. If you supply this inner 2 more variables, 1 or 2, whatever you give to this outer to be given to A, that's the first one. Then once you give this to, this outer will be supplied what? We pass them to what? To the inner. Because this S now, which is accommodating outer, is actually what? Housing also what? The inner. Okay? If you run this now, you have this. We can generate something. Let's just define something by ourselves. Say def. Okay? Let's say calculate something for us. What are you calculating? Calculate A and B. Once you calculate A and B, what do you want me to do with them? I also want you to define for me, let's say, sum. What are you summing? I want to sum something for X and Y. Then we come to this place now, okay? Then return, what are you returning? We want you to return X multiply by A, okay? Divide by B minus Y. I'm just doing something just to show you can do anything you want to do. What I've done now, 2 input will be supplied to this guy. One is taken by this, one is taken by this, remaining these guys, okay? Remember, I've returned for this inner, this is for inner. I've returned for this inner, this is for the inner. But what for the outer? Outer will return for us now, sum. We return sum, okay? Ends there. No need to pull this, okay? Once you have done that, if you want to call the outer now, let's say we call outer with D equals to Carl. We put 2 values because of these guys. Let's put now, for A, let's put 10. Then for B, let's put 20, okay? If we come in as a print D, I mean this D, if we give 2 value to this D now, these 2 value will be for what? These guys. Remember, this ones is for these guys. Any 2 value you put here now goes for this guy. But before we do that, let's put just 1 value here. That is for X. If we put like 5 here now, it will give us error. See? 1 is still missing because we have not finished supplying it everything. Okay? So this is for S. Say comma. We put something like 2. We run now, we have our output. So you see, that's to say, as far as this is concerned, this is S. S is here, that is 5. Multiply by, this is A, and this is A, 10. Divide by B. What is B? B is 20 minus Y. What is Y? Y is 2. It's equals to 50 divided by 18. And if you check it up, 50 divided by 18, 50 divided by 18, we have this. The same thing with this. Hope this is understood. Thank you for viewing. What if you want your function to accept variable length argument list? What is the meaning of that? Variable length argument list. Look at this. As you can see, this is a function that is used to do multiplication between 2 variables. Variable 1, variable 2. It only accepts 2 parameters, and you can't do beyond that. Okay, and if I want to call it here, then print with 3 or 2. If I run it, I have 6. But if I had put more than that here now, you see it will give me error. What is it complaining of? Say, mul, which is my function, takes 2 positional arguments, but 3 were given. Okay, let's assume I give 1. It will complain about that too. It's saying what? Mul, which is my function, missing 1 require positional argument Y. You see? Because the way I define this, I define it to be fixed. Only 2 parameters. You cannot take beyond or below 2 parameters. But what this one is saying is that, what if I want to have a situation whereby I can decide to put 1 variable, 2 variable, 3 variable, just make it flexible. How do you make what? Your function flexible. This is talking about flexibility. Okay, let's see what I mean. If I define this function again, for instance, I said this time, I want to define another function now. I say def, let's see VA. If I want this my function to accept variable length arguments, I will put asterisk. This asterisk is saying what there's room for variable length. Then I can put whatever I want to put. I can put S now. This variable length argument list. Then I can say, for instance, return S. I enter. If I want to call this now, I can put whatever I want to put. Put 1, 2, whatever, like this. Then I can run this. To show this, let me print it. Let's see, print this. See? What, for instance, I want to get the length of this, for instance. If I had, say I want to get the length of this. I can get the length of this. Let me just take this. Say I want the length. 6. How many are there? 1, 2, 3, 4, 5, 6. Okay? What if I wanted to add them together instead of this? I say, whatever I give to you, please add them for me. I say sum. How many are there? 32. If you add all this together, it will give you 32. Let me just reduce it so that you understand what I'm saying. Let me put again just 2. Without B2, this is 9. 9. Variable length. You can put 20, 100, 1 million variable length argument list. Hope this is understood. Thank you for viewing. Use a variable length argument list. Create a function to accept any number of integers, print each, sum them, and find the mean of the given integers. To do that, as you have heard, say def. Let's just say input. You can call it anything. That's the name I've given to my function. I simply put asterisk. Then I can give any variable name. Then I continue. It says we are going to find the sum. Okay. So I can just say total sum equals to 0 just to initialize. I can say num is equals to 1. I will use this one to divide this to have what? The mean. Remember, if I put 0 here, if you divide by 0, in case there is nothing here, it will give me what? Infinity. And you can't divide by 0. It's not possible. So I will initialize with what? 1. For the sum, I initialize with what? 0. So the next thing I will do, because I know that the user can give any number of input, I will simply say for I in LST. Okay, I'm looping through now. The first is say what? We need to print each. So each will be printed. We also need to find the sum. So this total sum that is here, remember we have to increase it by I. By this I. Okay. Then we need to also increase one. Once this one is increased by the value of I, then we also increase this one by 1. Remember, this is the denominator. So num, we put 1 here. So the next thing to do now is to come back and return this. We also return this divide by num. Remember, 1 was already here and it's coming from nowhere. So we have to remove that one, -1. Then we can put this in bracket. Okay? We are removing this initialization here. That's the reason. So let's run this. The next thing we're going to do now, let's call input. Before I call, I need to print this. Then I put, you see, each is printed, 4 printed, 6 printed, 2 printed. Then we sum them, as you can see here. Then we find what? The mean, which is 12 divided by 3. You have 4.0. You can continue because it's variable length. You can put here like 14, 16, 12, 10, any number of inputs, 30, 1000, or 100. See, these are each of the value given. This is the summation, and this is the mean of this group. So with this, I believe you understand how to use asterisk to make what? Variable length arguments. Hope this is understood. Thank you for viewing. Use the variable length argument list. Create a function to find the average of any given numbers. Okay? Let's do this. With def, we need the average. You can say num, any given number. Then we're going to say return for us the sum of num. Okay? Divide by the length of num. This is a function that will sum all the given numbers. This is a function that will find the length. If I give, for instance, 2, 4, 7, 4, then 2. This, we sum them together. This, we find a number that's 1, 2, 3, 4, 5. That's 5 in number. So the total sum divided by the number of elements will give us what? The mean. So all I need to do is to run this. To print this, just simply say this. Come to average. Let's give any number. We enter. See? 6.0. Okay, let's make it simple. Let's say 2, 4. Let's say 2 again. That is 8, right? Let's say 4 now. That makes it 12. Okay? These two produce 6 plus this gives us what? 8 plus this gives us what? 12. Total of 12. How many? 1, 2, 3, 4. Divide by 4 gives us what? This 3. Okay? In case you don't like what you have seen here, for instance, you see it's converted to float. You can from here define it that I want this result to come in form of integer. Okay? I only want integer. So if I run this now, see I'm having 6 here, right? If I run this now, I'm having this because by default it will come in float. But what if, you see, if I put 0.7, you see, so now we are having what? Integer, because we define it like that here. But this is not the original purpose. I'm just showing to you so that you not be confused or we are having a float when integer were given to this, because by default this return what? Float. Hope this is understood. Thank you for viewing. I am aware of this def average this, but what about this? Okay, this is exactly what we just saw in the previous challenge. We say we can return, for instance, sum of norm divided by the total number of norm, which is the length of norm, to give us what? The mean. This is not there. Then we run this. If we print this average, I put any length of numbers, the system was able to help us to get the average. So you are aware of this, but what about when you have a fixed variable before this, for instance, or you put a here as the challenge goes. In a situation like this, let's put this here. Let's say after. We are going to run this now. Remember, average has changed. It's no longer the same thing with this because we have introduced something else. I will put average 2 here now. I will take this and put before this. Put a comma. Then I remove this from here. Then I run this again. Let's see now. Now, if I call this average now, I say print average. Just average first. I want this number. Okay. Look at what I'm getting. What I got is, in the first one, remember I'm dealing with this one now. This is this. The system took this 3 because if you want to match, this one is in the position of 3. 3 was taken and was placed immediately after this average. So what the system did, it used all this to calculate the average. I placed the value here according to this return. This is the average position. This is the value. Then A, which is for free, is placed after because that's what we told the system. Now let me take this 5. I put here. I run again. You will see now that 5. Okay, let me even remove all this. Let's make it 4. Let's leave it like this. You will see now that A, we first of all choose. That is this first one. Wherever A goes, which is after this 5 will be placed there according to this place. Then whatever that is remaining will be used to calculate what? This. Because that is what this place is saying. If we run this, you see 5.0, that is 4 plus 6 give you 10, divide by 2, 1, 2. That is what this place is saying. Remember, 5 was taken a place for A. What if I just put something else here? Like, this is Python. You see, this is Python is the first here. It's taking a place after. Then we have this one used to do what? This calculation of what? Average, according to this place. What if I decide to take this one now? I say I want to use it for what? This average 2. I put 2 here. That means I'm coming to this place. The only difference is I put A before this average calculation here, but here after, here before. I want to do before now. If we run the same thing, you see we are having this one first. Once you have this given to you, this is the first thing, that is according to average to A is the first. Take this one, Even when you are returning, you return A first. That's why we are returning this A first before the calculation. But one thing you should know is that one thing you cannot do. Let me take this one out, copy a place here. I say now I want to put this A after this variable length. I say, okay, put A here for me. Let's run this. I run. Now let me call this average 2. Average 2 has changed, as you can see. Then let me put different values. Because the system do say, no, I can't do this. Why? Missing one require key only argument, A. Why? Because this A, because its fees should not come after this guy. You can do it here, you can't do it here. This should always be what? The last. Because this guy need to choose so that this guy can take the remaining one. Now, let me show you another one. If I say def anything, I say A, B, C. Then I put asterisk D. I say what I want you to do for me is to print A, B, I will say D before C. Only print for me. Then I come here and I say print for me anything. Let me put 2, 3, 6, 8, 7. I run this. What is going on here? Let's see. Remember, this none is simply saying that this type is none because it's not returning anything. But what I want you to know is that this guy is A, is the first, that is for it. Correct. This is B, the second, that is 4. So you can see, correct. Then we have C. This is for C, which is 6. Where is the position of C in the print is the last one. That's why you are seeing this. This is correct. Remain these 2, which is for this. Okay. We only ask the system to print them. That's why it's printing this. It's not adding them together for us. But if we have said, for instance, after you have done that, just sum D for us. Let's say return. If I say return, and this will disappear. Okay. Let's run this. If I run this now. See, the none is disappearing because we have something we are returning. Let's continue. You find that this guy continue to be 2, the first thing, because it's here first. B follow, which is 4. You can see. Then this C is 6. But where is the position of that print or that return? It's 6. That is the last one. What is remaining here at these 2? What happened? We only have the system to sum it together. And 8 plus 7, you agree, is 15. Okay? What if we want, after you sum it together, you also divide by the number of what? Element for D. Put D here now. That means we want to get the average. And if I run this, if you divide 50 by 2, you have 7.5. See? 7.5 now, because we have changed this function. I tell the function what to do with D. So D is everything that is remaining. Even though I continue to increase this, it doesn't matter. What it's saying is, these first 3, 1, 2, 3, they will choose. The remaining one will be used for what? For the calculation. And if I run this now, and I run this also, you see, the first one was taken for A, according to this place. The second one was taken for B, according to this place. Then this C is this one. As you can see, is the last thing here, is the last thing here. Then every other thing was used to calculate the average. What if I wanted to put here C in the place of this third one? I say, okay, what I will put, I will say hello world. If I say hello world, which is position of C, that means this place will be hello world. If I run this C, hello world. Up with this, you understand how to use this variable length argument list. Up this understood, thank you for viewing. You define a function, this. How do you pass elements in an iterable variable to the function? What is the meaning of that? Look at this. This is what you defined. Let's run this. If you want to call this now, you simply pass values to it. Then it will print this for you. It's okay. But the question is saying, we don't want to do this. This time, instead of doing something like this, we simply put this, for instance, we say asterisk X. we will still pass these 3 values to it without any error. Remember, when we define this, we did not use asterisk to define them, but want to pass value to this function using this asterisk. How? That's what the question is saying. If you want to do this, you simply have to put this one first as a list. That is 4, 5, 6. Then you run. A has this list now. If I put A here now, I have this. Now I can say num this asterisk A. What am I doing? I'm not telling the system, be very intelligent, Mr. System. Python, you need to be intelligent. I only have 3 values or elements in this variable called A. I know I've actually defined num in a normal way, but I want to pass this value here to num using this. When Python sees this and see that A has 3 values, it will share these values, this element, to these arguments. 1, 2, 3. So if I run this now, again, you see, I have this. This time, I'm going to make it to be B. I'm going to put here, for instance, put 100, put 1,000, I put 10,000, okay? Then I'm going to run this, 3. If I say num, then I come here, I say asterisk B. It means all this value in B, share it for the argument that were here before. Okay? If I run this now, see, I have this, like the reverse form. I know it was not defined with asterisk, but I want to use asterisk to pass my values to all the arguments. Remember, if I go ahead, for instance, let's say this time I want to do something like this. Let me make this one. Let's just do something like this. I run. I've changed the value of B. If I run this one now, the system will be confused. See, num takes 3 positional arguments, but 4 were given. I don't know what I should do with this because I was defined with just 3. Hope this is not confusing. If you have any question, don't hesitate to drop it in Q&A. Thank you for viewing. Write a function to accept any number of elements and print the elements in a row. Okay? This is simply to use, let's say num, the asterisk for what? Variable length. There is asking us to print them. Remember, when you bring this information in here, they will come as a list. You have to loop through them by say for I in A, print I. Remember, if you print like this, it will be printed what? Vertically, because there is one new line after this. Okay? We have actually treated this. Let me just demonstrate it. Num now, say for this. We run vertical, but it was asked to be printed in what? In row. That's why I'm introducing this. If I go ahead again, I can see them in row. If I want a separation between them, if I come here now, it's separated. Hope this is understood. Thank you for viewing.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Write the function to accept any number of integers and find the average, the minimum, and the maximum number of the integers. We're going to use the variable length, def. Let's say integers. Then we put asterisk. Let's put none. Then, first of all, we need to find the average, then we find the minimum, then we find the maximum. When it comes like this, the best way to do this, can say return. First of all, when it comes, we take num, we should what? Sort it first. We're going to put sorted. After sorting, we should be able to find what? The minimum, which is me, comma. Let's find the maximum. The next one now is to get what? The average. The average will be the sum divided by the length. We don't need sorted here anymore. Just only the sum is okay because we don't need to sort before we sum them together. Then we do this. Let's return. If we call integers now, let's put any number. This alone will give us 13. Let's put 3 to make it 16. If we run this, see, the first one, the minimum, it says 3. Are you agree with me? The maximum is 6. And the average, if you add all this one together, divide by 4, give us 4. If you actually want this one to be returned in the form of integer, all you have to do, you can just wrap this one I say, I want it to come in integer. If I run again, it's coming back what? In the form of integer. And remember, if you're not using Jupyter Notebook, you have to actually put print to see your output. Hope this is understood. Thank you for viewing. What about this? 2 asterisk, the KW asks. This simply means keyword argument. Arguments. What is it all about? You remember we did something dictionary where we say, if you want to do dictionary, you say key, then the value, comma, key, then the value, comma, key, then the value. Can put A here now, say 2, put B here now, say 4, put C here now, say 5. Whatever you want to put, keep value pair. The same thing. In case you have things like this, to run with a function, we use 2 asterisk to indicate 1 asterisk for the key, 1 asterisk for the value. But the way it is done here, it is not with this. It is done with what? Equal to instead of what? Colon. In place of this, we put equal to. And we don't use this curly bracket. Let me explain to you. It all started from this place. Say def, that's the names. We put, say A, B. For instance, we say print A and B. We run. If I want names now, I will simply come here, put Dave. Let's put Dave. Then we put Mike. If I run this, I have Dave Mike. Then we upgraded it. We said instead of you to trouble yourself with all this, simply put asterisk. Put anything you want to put. I can put A as well. Then I can say print A. With this, let me put 2 here now. With this, if I want to call this, I can put any length like Dave. I can put Mike. I can put even another one like James, and so on and so forth. Name 2 is not defined because, sorry, I should put S here to run. Okay? The same thing. You see? Even though if I make it 2, I will still have this. If I make it 100, it will still come out what? Fine. Now, we now have what? Another one. We are now calling what? Keyword argument. But what is the name of this one? This one. This is what? Non-keyword argument. Why? Because there is no key involved in this place. But for this one with 2 asterisk, it means the system should be expecting what? 2 pairs, which is key and the value. If I leave it like this, for instance, I can come to this place now. I say print for me. Before that, I can simply say, because I know it's keyword now, to access them, I say for I in A, print I represent the key. What about the value? The value will be this A, then I. Why? Because you agree with me that if A, for instance, is equals to, let's say, name 1 equals to Dave, name 2. This, to access this value, we say A, we put the key, which is name 1. And as you can see, this I, which is this I, is going to get me what? The keys. What is this? Key, the first key. We can have another key here. We can have another key, and so on and so forth. So because I here represent the keys, I can also put it here. Instead of putting the actual key, this I represent all the keys. Whatever key you guess to, put it here. Give me the value. That is the meaning of that. If I put that, I can now say what? This. Print this for me. If I ask the system to print this for me, I enter. The next thing I'll say name 3, come to this place. I say, for instance, name 1 equals to Dave. Name 2 equals to James. Name 4 or name 3 equals to Peter. If I run this, you see what I'm having. Please don't confuse this with this. This is just key. Does not have anything to do with this. Okay. If that will confuse you, let me just put NaNa. Okay. Then I run this. What you should see now is that this system knows that this is key value pair. And as you can see this place, I did not put this quotation mark. There's no quotation mark. If I dare put quotation mark here now, look at it. Error. Expression cannot contain assignment. Perhaps you mean this. No, you can't do that.
This is the place we are interested in. And also, you can't put just this the way you do it in a dictionary. Error. So just put whatever you want to put. I can put name. I can put name 10, whatever. I can put here to name 14 or 12. If I run this, I'm okay. Also, I can tell the system that in between this place, I want you to separate with asterisk, separate with column. Then I run this now. See, separated with column. I put equal to here. Whatever you want to put there, you put. You are still correct. So whenever you see this, it means that what? We are going to deal with what? Key value pair. That's what we call it. Keyword argument. But if there's not going to be any key to access them, there's no need to put two asterisks. Another way I can also do this, let me just come here now and make this one 4. This is not actually for this. I'm just explaining further. For I can do something like say for key, for instance, and value in this place. To access it in this format, that means from beginning, I want to separate them. I have to tell the system to help me using what? Items method. Then I will come to this place, print the key, come to this place now, print what? The value. From this place, I've done the separation. There's no need to do it here anymore. Then if I run this, I copy this again. I put 4 this time. We have this. If I put double here or triple, if I run this now, I have this. The purpose of this is to let you know that this one means what? Key value. And for that key value, it's not the one you have in dictionary. It's the one of what? Equal to, equal to. All this is understood. Thank you for viewing. You've defined a function. This function. Now, how would you use the keyword argument to call the function? This is the function we've defined. If I run this, best way to call this, you pass 3 arguments. You have this. But now, challenge is asking us, what if we have a key value pair system? That is to say, assume I have u equals 2. Then I have the following. What I've done is, I can even put this one true. Let me put this one true. The reason for this, just to show you that, remember as we said, when we are treating dictionary accept different word values. But this key, as you can see, they correspond to this. Exactly the same thing. I don't need to change them. If I run this dictionary, if I put you now, this is just dictionary. I can use this norm with the dictionary to asterisk. It's telling the system that expect a key value pair system. Then you. If I run this, I have what? This one, then the true, then this is Python. If I change this, let me assign it to a different variable now. Let's say F. If I put A here, for instance, just A, put B here, for instance, it won't work anymore. If I want to call the norm with F, see error. Norm got an unexpected keyword argument A because it was expecting X. Or like the one we did in non-keyword argument, where we are calling a function with a non-keyword argument. It doesn't matter if you use what is defined here or not. What I mean, if I had this one now, for instance, I say P is equals to this list. You can say it's P. I put here. Because this one has nothing to do with what? Keys. So if I want to call num2 now, I can still call num with P. But this time, to show that it's a list of arguments, I can put P here, then one asterisk. I can still call num. But if I want to call num with key pair, the key pair must come with what was used to define this num. S, Y, Z. The key side of it must be what? S, Y, Z. If it's not S, Y, Z, you're going to have issue. Okay? For instance, I put this one here. Then I put, say 2, put here 3. If I run this, I can still call num with this dictionary. I have 1, 2, 3. Hope this is understood. Thank you for viewing. What is recursive data structure? What is recursive data structure? If there is any data structure that can produce a smaller version of itself, such a data is called what? Recursive data structure. How do I mean? Assume that this is a data. A is able to produce a smaller version of itself. I say A minus 1. Or this is B, produce a smaller version of itself. Let's say B minus whatever. Let's say 4. This one goes further to subtract, say 2. Goes further to subtract 3. This is what? Recursive. This one can go further to reduce itself by 8. Goes further to reduce itself by what? 12. This is called what? Recursive data structure. This is the same method we use for factorial. Assume there's factorial.
Say find the factorial of 10. Can say it's 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 by 4 by 3 by 2 then by 1. As you can see, each of these is reducing itself by 1. This is called what? 10 factorial. Okay? What if you have a situation whereby you want to have this like this? Let's say 5 plus 4 plus 3 plus 2 plus 1. The next one in this series is be reduced by 1. Or you have 10 plus 8 plus 6 plus 4 plus 2 plus 0. This is called what? Recursive data structure. In our next challenge, you are going to see how to use function to run this. Hope this is understood. Thank you for viewing. With recursive function, calculate the sum of integers from 0 to 6. So the first thing we're going to do now is to define a function. Say def, just say sum. Let's say to calculate what? Sum. Then let's put here a. I'm going to say if a is equals to 0, return 0. Hence, return a plus this minus 1. Okay? The next thing I need to do now is to call this function. Let's say print the function. What am I going to put here? Let's put 6, 21. And if we calculate it manually, that is to say 6 plus 5 plus 4 plus 3 plus 2 plus 1 have 21. Now let me explain what is going on here. Look at it. We define a function and the function is called sumCal. We put what? The parameter. First of all, we want to make sure that a is not 0. If it is 0, just return 0, but there's no need to waste our time. Remember, you can use this function to do any addition of what? Of any numbers. Any numbers. Can be 10 to 0, 1 million to 0. Okay, to prove that, let me put here now, let's say 1000. You see, this is the result. But we use 6 for simplicity. Once I am through with this, that this is not 0, that is, the value that we gave you is not 0. Then all you need to do, return the value I gave to you. Here 6. Then use this one now for me again. What is this one? I'm adding to this. I'm adding this O function. This one is the O function. Let me show you again. This particular one is this O function minus 1. That is to say, whatever value I gave you here, reduce it by what? By 1. If you look at this place, is 6 plus sum underscore cal, then 5. What do you think that this guy will give to you? Plus, this one also will give me what? Here, as you can see here, 5 plus sum underscore cal to give me what? 4. Reduce. What will this give us? 6 plus 5 plus 4 plus sum underscore cal, then 3. This one will give me again 6 plus 5 plus 4 plus 3 plus sum underscore cal 2, and so on and so forth. Until it continues, let me come to this place. 6 plus 5 plus 4 plus 3 plus 2 now plus sum underscore cal, then 1. This one will give us 6 plus 5 plus 4 plus 3 plus 2 plus this sum cal will give us 1 now plus sum underscore cal 0. And remember we said if it is 0, return 0. So 0 will now be returned here. That is, you have to add 0 to all this one. And anything you add to 0, it will be that thing. If you add 0 to anything, the thing remains the same. That's what we have done. That process is called what? Recursive. The process of what? Recursion. Okay? Hope you understand this. Let's go straight to the next challenge. What is the difference between the same name variable inside and outside of a function? The first thing you must know is that the variable inside the function is called what? A local variable. While the variable outside the function is called what? A global variable. Okay? Let's say S is equals to beautiful. This is what? A global variable. So let me define the function. Let's say a func. Let's say SCNI is equals to answer. Let's print here S. Then we go down here now to first of all print this S. That's to say print S. Then we call this function. But this function is meant to print the S inside this place. Okay. What I will do again, I want to go back again and repeat this S. What am I trying to do? I want to prove to you that this S and this S are not the same. This is global, while this one is what? Local. If this S and this S are the same, it means that this you give me beautiful, then this one will give me what? Handsome. Meaning, I started with beautiful. Inside this function, I change the variable. But it is not possible because you cannot change a global variable inside a function. No, you can't do that. If I run this now, look at it. This guy pretend this for me, which is this. Okay? Then this function use this guy to print this answer, which is this. What I'm doing here is that I was trying to update this variable in this place to another name. Inside is looking at this as what? A new variable. Because if it is the same thing, when I try to print this S again, it should give me what? Answer. Because they are not the same, that is why we are not having what? That lock. Okay? But what if I want to do that? If I want to still what? Change this S. What I will do, I'll put global S. This one is telling me that any S I will use inside this function, I'm referring to this global S. Any S we are going to use inside this function is referring to this, not another S. That is the work of this global. That is the way to bring this guy into this function. If you look at this print now, let's run. You see, because we have told the system that this and this are the same, it printed this with this. It gave me answer. When I asked it to print S again, it still give me answer. That means this has been what? Updated. This has been changed. Okay? Is it possible to use a local variable outside of a function? If no, what can we do to use it? Def is, for instance, let's say my function. I say f is equals to 300. This is a local variable. If I come here now, I say, okay, my function, then I say, okay, I want to print f. If I run this, it say what? F is not defined. Remember, I want to use this f outside this function. That is the reason why I'm doing it directly outside this function. I can't do that. The only way to do this is to first of all declare this guy as what? A global variable. If I run this now, I have access to it. Okay? So whenever you want to use a locally declared variable outside of its function, you tell the system that this is going to be used outside the function. That is why I'm telling you what? It is global. So you are telling the system what? This is global. Please allow it to be used outside this function. We have answered these two questions. Can we do it? No. If you want to do it, what do? Use global. Hope this is understood. Thank you for joining.
What is lambda function and how is it used? Lambda is anonymous function. It's anonymous because when you want to define a function in Python, all you need to do is to use def. Then you give the name of the function. Then you put your statement already indented in this place. Remember, there is def and there is a name. But for lambda, there is no def and there is no name. It means what is what? Anonymous. There is no way to know which function is this, which function is that. How do we use it? If you want to define a lambda function, say lambda, then you put your argument. Then put what? An expression. Okay? This is your argument, the input that is coming in.
This is what? The engine where the processing will be done. For instance, I can get a variable s, for instance. I say this time I want to add two numbers together, but I want to design a function for it. Normally what I should do if I want to do that, I will simply say def. I want to add, for instance, two numbers. I say a and b. Then I will go ahead to say what? Return a plus b. This is enough. The next thing I will do to get the output, I will simply say add. I can say 6 and 4, which is 10. Remember, while I was designing this, I used the add as a name after the def. If I want to do the same thing using lambda, which is anonymous, I will say lambda. Then you can see here now, these are the argument. The argument are what? A and B. I will say A, B. Then the expression. What do I want to do with A and B? I want to add them together. Okay? You want to add them together? Okay. Now, I want to assign this to a variable. Remember, I'm just assigning them to a variable. Let's say VL equals to this. Then I enter. So now, next time, if I want to get this, I can simply say VL 3 and 4. Remember, this will give us 7. If I run this, I have 7. You see the way I'm doing it? This has no name. This is not the name of this function. This is just a variable where it is living. This is the way to use what? Lambda. Hope this is understood. Thank you for viewing. Write a lambda function to add 1000 to any argument. What is that? To add 1000 to any argument. If you want to do that, assign it to any variable, lambda. Remember, we need to put the argument. Could be anything. Let's say C. They want to add 1000 to it anytime. So C plus 1000. This is it. It means now, if I want to add, let's say 500 to this, I will simply say R 500. The result will be what? 1500. If I say arrow now, 99. It will be what? 1099. This is a function, anonymous function, written in Python to add 1000 to any what? Argument. Hope this is understood. Thank you for viewing. Write a lambda function to multiply any 3 arguments. Let me say this equals to lambda. Then 3 argument means, let's say A, B, C. What do we want to do with them? A multiplied by B multiplied by C. Then we run. If I say D now, I put 3 arguments. Let's say 2, 3, 4. You agree with me? This will give us what? 24. If I run this, I should have 24. Another 3, let's see, 10, 20, that's 200. Then let's say 2, that's 400. See? This function, written in lambda, an anonymous function, is to what? Multiply 3 arguments together. Any 3 arguments. Hope this is understood. Thank you for viewing. Is it possible to use a lambda function inside a user-defined function? If yes, demonstrate. Yes, it is possible. This is a user-defined function. I want to call it multiplication. Then this multiplication, let me just put one value, say A. What do I want to do with this? I don't know yet. What I want this system to return for me, or what I want Python to return, tell me what? A lambda. And this lambda has only one what? Input or argument. The argument of the lambda, I want it to be multiplied by that of what? The user-defined function, by the normal function, multiplied by B. As you can see, this argument is for the normal function. This argument is for lambda. I want to multiply this by this. Let's see. If I run this, no error. The next thing I want to do now is to assign this normal function to a variable. Let's say the variable is this, equals to mul, let's put 4 and enter. Okay, now I want to print this particular variable. If I come here now, I come back here again, I put say 3. I should have 12 now. Look at it, 12. Why? What is going on? Let me explain to you. Look at it. After I defined it, I assign everything to this function, which is this, with this initial what? Argument. As you can see, this argument goes for A, because when you come into this place, the first thing you will meet is this A. The first argument is A. Then now, this is now what? Another function of its own. If I want to assign this here now, which is another argument, is going for the second one, which is for the lambda. Remember, there are 2 here and here. Now, let me explain that further. If I copy this time, I want to do for 3. Here, I want to put 2. A and B. I will call this one as C. I call this one, let me put T here now, just to make it different from the other one. I run this. I want to assign this to R. So MULT, assign to R. 2 and 3. I enter. If I want to print R, I must print it as a function. They put another argument, let's say 4. If I run this now, I should have 6. The reason why I'm having 6 is this. You remember, this is for this is for this. And this expression says only work with what? A and B. So even though I assign 4 here now, it doesn't change anything. Still remains 6 because 2 times 2, according to this expression, is simply what? 6. What if I remove this from here? I run it. See error. Why? Because there is what? Another what? Argument. That's what? For lambda. So let me come back here now. Put 4. Run again. Then I will come to this place now. Say multiply by C. If I run this, I come here now. I still run this. I come here now. I run this. I should have 24. You understand? Remember the way it comes. This first 2 for this for this. It depends on what to express here. That's what we give you what? The output. For instance, if I have said I only want A to come out, it's okay. If I run this, I run this, I have 2 because I told the system that it's only 2 I want as the output. That's why 2, which is for A here, was given to me. Hope this is understood. Thank you for viewing.
How does map function works? So in this section, we're going to introduce map function. What is the work of map function? Let me show you. You agree with me that a list is iterable, just as set is also what? Iterable. But let me use list to explain this. If I have this type of item in this list and I decide to multiply this by 2, multiply this by 2, multiply this by 2, and multiply this by 2, that means each of the item multiplied by 2, definitely I will have this. I will have 2, 4, 6, then 8. Multiply each of these by 2. If there is a function that can help me do this, I instruct the function saying, help me what? Multiply each of these by 2 without using for loop. It will be a great what thing. Let me show you. That I've said now can be done with map function. I will simply say function here, then I put the iterable here. This iterable. So this is the instruction. This instruction, which is the function, will be applied on this what? Iterable. And you agree with me that this iterable. So I need a function that will help me multiply each item here by 2. Let me go back again and comment this. Now let's do a function def. Let's call it mod. Let's call it mod. If you give it a value, it will return the value multiplied by 2. We run. So this is the work of this. So if I say mod, then I put 2 here, for instance, I have 4. If I say mod, remember I need to use print anyway. Remember I have to use print to actually do it. If I say mod, for instance, I say 4, I have what? 8. Now that I have a function that can do this work for me, that can run this type of thing for me, all I need to do now is to come back to this place. Let me just copy it. I will say I have a function to do this work for me, and the function is called mod. Remember, I'm not putting the open bracket or close bracket. Then I copy this iterable, then I will put it here. Then I run. If I want to, let me put this one somewhere. Let me just print it. Let me assign it to V. Now, what I will do, I will list V. I have what? 2, 4, 6, and 8. Remember that this is the function saying what? Multiply each of these by 2. That multiplication is coming from here because that is what this function does. I want to do another thing now. If I have map, I say, okay, I want you to put everything here in float. Let me say I have this, all this. Remember they are integer now. Say, okay, I want to convert them for what? To float. Let me say C equals to this. Say, I say list C. You see, each of these now is converted to what? Float. What is it? This is the action. This is the work. This is the item in iterable. So these items will be passed to this function one after the other. 4 is given to the function, convert to float. 5 is given to the function, convert to float. 6 is given to the function, convert to float. 8 is given to the function, and so on and so forth. 7 is given to the function. 8 is given to the function. Just in this place, I first of all define this function because it's not inbuilt. But you agree with me that this float is already an object in Python. What if I have all these, for instance? Let me just say CC. I put 0.0, 0.0, 0.0, 0.0, 0.0. I want you to convert everything here to integer. I run list CC. See, this is the action to be applying on this.
So that is the work of map. Map will help map the function to the iterable. Each item in the iterable will be what supplied to the function. So the function first, then what? Whatever you want to do. That's how it works. That's how it works. So in this section, we are going to look at many instances of the map. I believe this was informative. Thank you for viewing. Write a Python program to square this tuple. The first thing we need to do to define a function, let's call it square t. That is the argument. Then we return n raised to power 2. This is squaring of what? An item. Or we simply say what? N multiplied by n. We enter. The next thing we need to do now, let's say result is equals to map. Let's map it now. Then we put this tuple. Either you put it direct or you put it in a variable. Let's say t is equals to this. So I will put t here now, then run. Now to have what is here, if we put it like this, we tell us that what? Map is located here. How do we see this result? Because it's a tuple we want to see, simply put what? This. The reason why we are having this curved bracket is because we use tuple. If we use list, see, no result, but we have this. If we have used set, see, no result, we have what? This. But what you should know is that this is iterable. What we are interested in is that what you are passing to this function in map must be iterable. If this was a list, for instance, let's just pull this from here, put it here. This should have also be a list, for instance. Then we put L here. Let's make this one L. Let's still use the same function. Let's call this one result2. Return. So list result2. So we have this in the form of a list. Okay. But remember that if we use list here, assume I put here as a list, you see, there was nothing because what we supply was a tuple. Here we supply what? A list. So you have to use list to call it. Okay. What if I say, okay, I want to call this with a tuple. See, nothing is returned. What if I want to call it with a set? See, nothing is returned. Because this was what? A list that was supplied to the system. Therefore, you call it what? With a list. In summary, what we have done is, we first of all define a function because we need a function to put in this first location. Then we supply what? The items in iterable. Hope this is understood. Thank you for viewing. Write a Python program to add corresponding items in 3 different lists together. Assume we look at this, let's say list 1 equals to, okay, we say list 2 is equals to corresponding, okay, list 3 is equals to, okay. Assume we have these 3 lists. Let's get a function to add items together. Because there are 3. We say, okay, return A plus B plus C. Okay, now we need a map. Let's say output is equals to map to what? To list underscore 1, list underscore 2, list underscore 3. Then I run. Then let me get the output to show you the result. Now let's get the result. If you check, 3 plus 4 is 7, plus 2 is 9. 4 plus 6 plus 3 is 13. Because it corresponds the item. We first of all define a function that will help us realize this. Then these are the values passed to this what? Function. Map knows that the first thing that will be here before the first comma is the function. Any other thing that is coming remains what? The input. If you remove this, for instance, you now run this, you still have error because here we have what? 3 inputs. Here we are giving what? 2 inputs, which is not right. Hope this is understood. Thank you for viewing. Can lambda takes the place of a normal function in map? Let's see. If we say map, we normally put function here. Then we put what? The iterable. So the question is saying, can we replace this function, which we normally define first, with lambda? Of course. All we have to do is say lambda. Assume we want to define a lambda function that double an item. Let's say this is the item. Then we multiply the item by 2. This how to double an item. Let's put an iterable here now. The iterable we are putting, let's just put this. So we ask this lambda to help double each of these what? Item. Remember, lambda is also what? A function, but it's an anonymous function. So what it means that this is the argument. This is a statement saying multiply by 2. If I run this now, let me put it in a variable. Let's say v equals to this. All I have to do is to list it. Then we have what? 8 multiplied by 2, 12, 14, then 16. You can see that the lambda now is taking the place of a function. So it is possible. As long as you know what you are doing, you can use what? Lambda to replace what? A function. Hope this is understood. Thank you for viewing. Using lambda with map, add the corresponding items in this list together. Okay, these are the two lists. I'm going to copy them. I'm going to call this one A equals to this. I will call this B equals to this. Then I run. The next is to use map. Let me see result is equals to map. The lambda function, two items. Let's say N and M. What do you want to do? I want to multiply N by M. So this is the conclusion of what? The lambda function. Any other thing now after this comma are the attribute. They will run. Let's list out what is a result. See, if you multiply this by this, you agree with me that you have 12. If you multiply this by this, you have 6, and so on and so forth. Hope this is understood. Thank you for viewing. Using lambda with map, triple this set. Let's say t equals to map. You need the lambda, then want to triple something. And to triple something, we simply say what? Raised to power 3. Or you can simply say n multiply by n multiply by n. Either of them. Let's use this one. This is what? The action. But the argument is this, n. The next thing we need to do now is they will run. Let's see what we have. You see, if you triple this, 2 times 2 is 4. Multiply by 2 again, you have 8. 3 times 3 is 9. Multiply by 3 is 27, and so on and so forth. Hope this is understood. Thank you for viewing. Given this, find the length of each of the words. The length of each of the words. And you agree with me in Python, we use len to find the length of what? Of a word. If I write something like this, Python, I have 6. Good. So what I'm going to do now is to simply say what? Y is equals to, then we say map len to this tuple. First is what? Able to length. If I want to see what is the output, I will say tuple. Then we run. We have here 4. This is 2. This is 5. Remember, we did not put this. Open and close curve bracket. If you want to use an inbuilt function, just put it the way it is. Only the name is allowed. Don't put the open and close bracket. Hope this is understood. Thank you for viewing. Write a Python program to return true for even numbers in this list. First should be returned for odd numbers. Okay, let's call this one num equals to this. The next thing we need to do is to define a map. Let's say result equals to map. Let's use lambda. We put, let's say I, then we need to test. What are we testing? If we can divide I by 2 and the remainder is 0, then that particular value is what? Evil. So true will be returned. So let's put num here. Let's run. Because it's a list, let's check the result. See, this is evil, this is evil, this is evil. This is what? Odd, odd. Hope this is understood. Thank you for viewing. Given list is equal to this, write the Python program to get the absolute sum of the items. Okay. The first thing we need to do is to first of all drop this. Now let's write the sum of what? Map ABS, which is the absolute function that will convert anything negative to positive. Then we put the list here. What we are doing here now is we first of all convert these items, all of them, to positive values. So this negative will leave, this negative will leave. That is the work of this. Let's see, we have 18. Now let's add it together. What we are adding now is simply this. This will give us 7. This will give us what? 12. Then 18. If you want to sum this now, for instance, let's sum it. Direct C. And we are right. We have this. If you sum this with negative values, you have -4. You see? So the question says we need absolute sum. That is why what? We first of all convert each of the value to a positive integer using ABS and this before we sum the list together. Remember, this is iterable. The result of this will come as what? As a list. This one work with what? Only what? Iterable. If you say, for instance, sum 4 and this, cannot get it unless you put them what? Inside what? A list. Hope you know how to use sum. I believe this is clear how to use map ABS to get this solution. How does Python generator works? Look at this. Let's look at even numbers. Let's say start, end. The work of this function is to generate even numbers. Okay, we have 2 parameters, 2 arguments, start and end. Okay, and to do this, let's use the for loop for I in range. Let's say start and end. Let's add one to it because for range, where it will end is less than a number. So we have to compensate that by adding this to it. Because it's even number, we'll continue to add 2 to it. Then the next thing you need to do now is to say print I for us. Let's look at this. If I enter, let me say I say G is equals to even number. Let's say we're going to start from 2. Let's end at 20. Look at what I'm getting. 2, 4, 6, 8, 10, 12, and so on and so forth. That's what it's producing for us. We have not seen generator yet. This is the way this one works. Now let me show you how generator works from here. You are used to this. Let me show you how generator works. I will change this one out to yield. Okay? I'm going to say yield I. Yield I. Now let me go back now. Do the same thing. Let me say this time G2 is equals to this evil. We start from 2. We see add at 20. Now let's run it. How do we get all this value? If we look at G2, let's see what is there. You say what? This G2 has what? A generator object. What this one means is that instead of having everything at once printed out, we should be using next to what? To get to each of these. That's what we're going to do. All these values are already stored in this place. Okay? But how do we get them? If you want to get them, you simply use next. Then you put G2. Let's run this. You see we have 2. I will copy this now. I run again. We have 4. I will copy this. I run again. We have 6. You can see we are having then 2, 4, 6. All the even number. 2, 4, 6. All these are the remaining ones. Okay. So let me just continue to hit run in the same place. That is 8, 10, 12, 14, 16, 18, 20. This is called generator. We have exhausted the number. If we try to run again now, it's giving us what? This exception. Because we have exhausted everything. This is called generator. As you are clicking next, it's like it's generated them. Generated 2, generated 4, generated 6, generated 8, and so on and so forth. The reason why we are having this is because of this yield. Yield is a work. Okay, let's also try another one. If I say def odd, I will say start. Let me just leave it like this, odd. Okay. This time, let me say I is equals to 0. I will say y I is less than 21. Okay. I will say print I. But what you need to do for me is to still continue to add a number to I. Okay. Do it like this for me. Then I run. If I run this, let's see what we have. Then I just pick this odd. Let me not start from, because I'm looking for odd numbers, let me not start from 0. I will start from 1. Because 1 is odd. Okay. I'm saying I is less than 21. Print I. Okay. But all you need to do, continue to add 2 to it. Okay. Let's do it like this because we're not just going to generate any number. We are generating odd numbers. So let's run again. If I take this now, you see that all the value there will be given to me. You see 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. These are all odd numbers. Before what? 21. Okay. If I remove this one here now, I say yield I. Okay. I'm going to copy this so that you separate it from the other one. Yield now is replacing print. This yield will act as a generator. We'll be yielding them for you one after the other. That behavior is called what? Generator. Let's run. Let's still put this all there. You see, it's telling me that there's a generator here. I can't give you all the value the way I drop them for you. What is a generator? You are meant to generate them. It's not meant to give it to you at once. So all we need to do now, let's just assign this to something. Let's say G3 is equals to odd. Okay. Then we're going to see what is what at G3. The first is 1. We run again. We have 3. We have 5. See? Generated them one after the other. These values are all available already in this location, but you have to use next to get them. This is how generator works. Once it finishes, tell you what, stop iteration. This is how it works. Let me also show you another thing. I'm going to copy this again, run this again, run. But this time, I know what is here already. I know it's the generator. But which other way can I use to get this? I can use list to have them in the form of a list. So I want you to list them for me, what is there. Or you can put this evil to a, let's say to a variable. We run this. Then we take this instead of putting it here like this. This is still correct, but just make it, see? These are all the value. It's listing what is stored here. As I said before, you can just actually run it direct if you want instead of doing that. So just copy this now. tell us what is inside here. These are the values that are stored here. Now let me come here again, run this. This time, instead of using nest or using list to get what is here, okay, you can just say, okay, for instance, let's say GC equals to even. We start from 4 this time, we end at 40. If I put this one here now, you see it's a generator. So the values are already stored here, but we need to generate them with nest, or we want to list them. Which other thing can we use? Because we know that this is like a list, it's iterable. Because if you see this error it gave to us here, stop iteration. Because it's iterable, we can actually use for loop for I in G6, print I. I'm going to run through them now. You see, it ran through them, I printed everything for us, all the even number. Either you use nest, or you use list, or you use what? A for loop. Okay? Hope this is understood. Thank you for viewing. Using generator expression, generate the square of this list. What is generator expression? I want to introduce to you the meaning of generator expression. Let's see. If we have this list, let's say list is equals to, let's say ls equals to this, 2, 4, 6. This is what we are given. For instance, I raised to power 2 for I in ls. Okay? If we run this now, we have everything here squared. So what is generator expression? If you want to have a generator expression, simply remove this square bracket and put a curved bracket. I'm going to assign this to a variable g. Then I run. If I put g here now, you see, say what? G is housing what? A generator object. So if I want to get what is there, I can print, say next g. See, the first one is printed, it's generating it now, or like this that just gave me all the results. If I come back, I click the second one, if I come here again, I click, I have 36. It means if you use this, it will put the whole thing in the form of what? Generator. If I run this again, for instance, I can also list what is in G, just the way we did the others, because this G is housing all this one. You can as well loop through all of them. If I run this now G has the generator. I can say for I in G, print I. As you can see, if you don't want to have vertical result, you can as well say end equals to. If you run this now, so we run this again, then we run this again. See, we have them what? In this format. All these are already treated. Hope this is understood. Thank you for viewing. Using generator expression, calculate the sum of the square of the odd numbers between 1 and 11. Generator expression, we need a square. What are we squaring? For s in range 1 to 12. Remember, we are talking about to 11. That means 1 before this end. And if we want to progress, we go by 2. That means 1, 3, 5. Okay, let's list it to show that we are correct. If we run this, we have the square of odd numbers between 1 and 12. This is 11 square, this 1 square, as you can see. But this is not the question. We are asked to sum them together. Sum. We sum it now, we have this. This is one way. Another way is to say sum. We want to square for x in range 1 to 12. No need to use this 2 this time. We just put if we divide s by 2 and we have a remainder of 1, it means it's an odd number. Then you can what? Use it to do the addition. If we run this now, we have the same result. Hope this is understood. Thank you for viewing.
What is a module in Python? A module is a Python file containing set of functions and variables. That is to say, if you have a module, contains what? Functions and variables. These variables could be of any type, could be of array, could be of tuple, could be of dictionary, could be of any object, and so on and so forth. So a module could be a user-defined module, that is, the one you define by yourself, or the one that is shipped with Python. That is what? The inbuilt module. What I'm saying, you can either build a module by yourself, such we call what? The user-defined module. Or the one that is what? Built in with Python. The one that is shipped with what? Python. Either of these. Okay? And remember that if you want to define your module, for instance, you want to create your own module, once you finish with your code, you have to save that file as .py. Okay? Now you have created a module and the name you gave to the module is my module. Then you say what.py. Now you want to use this module in your program. All you have to do is import my module. Okay? Then you can use the available functions or variable inside that module that you want to use. So in this section, we are going to look at a lot of challenges that will help us to understand how to use module. I believe you enjoy it. Thank you for viewing.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.